essentially a Unit 1 pure maths exam in disguise. If you could do that paper, nothing gonna scare you in that exam at all. Right.
The paper, you check I could get it.
The insane.
No, I'm now joined, so I won't have all the other messages.
That's not a problem. That insane paper kind of insane though. Like it is. I feel
I'm
like
not good. I got good math students. I think it was it.
okay, no problem, no problem. Let me just make some of you guys a co-host. Big up the Nat Rampasad. He's a teacher. It's one of my past teachers from Shiva Boys in the college. Right? He's just curious. So big up the
Yes,
Nat
I know who
Rampasad.
that is.
Yeah, boy. Hey, look, Mikel. I don't know if the Nats. Yeah, Mister did not know who Mikel is, but
He's supposed to. Yeah.
yeah. I'm gonna assign him as co-host. He go add people into the meetings. Nikolai, I'm gonna assign you as co-host as well. You will also take that role. Mikel, I trust you. Make you co-host. Good. All right, let me just make sure we live on YouTube.
Yeah, I just got a notification.
Okay, good. Are you ready for the ad maths grind? Late night ad maths grind.
Yes, sir. I'll pass
Yes.
on maths, sir.
Well, will pass ad maths. Somebody could just admit all the people that waiting.
Yes, sir.
These days, I listen to a lot of Michael Jackson. I don't know if it's just me though, but like,
Ever since you was, oh, you was singing that
Mhm.
songs.
Nah, so
yeah,
Katy
boy.
Perry been on Spotify for me recently.
I see Katy Perry and maths vibes for you, boy. All right, so let's jump straight into it, right? This is like a quick pop quiz. All right. Okay. All right. Quickly, for a line, do we need a gradient function?
Yes.
Do we need to find the gradient function for a line?
No, sir.
No,
No.
sir.
Because for a line, the gradient is the same at
Every point.
every point. Good. So there's no need to find the gradient function for a line. What about for this cubic equation over here? Is the gradient the same everywhere?
No, sir.
No,
It
sir.
changes.
No, sir.
Gradient changes. So we'll have to find the first derivative. When you find the first derivative of any function, that tells you the gradient of the what? The normal or the tangent?
The tangent.
Tangent, sir.
Tangent. Ooh, we're gonna roll today, boy. Everybody that come yesterday, we cooking on like on gas. So quick recap. What exactly does dy dx mean? Quick recap,
Changing
right?
one by changing X.
Right. And it essentially tells you the what?
Gradient.
And specifically, it's not just a gradient, it's a gradient function. Why is that? Because it doesn't a function accept an x value and it gives you an output?
Yes, sir.
Right. So gradient function. And again, guys, does this give you the gradient of the tangent at a point or the gradient of the normal at the point?
The tangent at the point.
Tangent.
Tangent. Gradient.
The tangent, not the normal, right? If your CSEC being a little weird and they're talking about first principles or limits or anything, that means you have to do first principles. And that is defined as the first derivative is equal to what? Remind me.
F.
Limit of
Limit
plus
as
one.
h approaches
as
zero.
h tends to 0. F of x plus h minus
And if
f of
And if you're confused, I went through this in extreme detail in the first life. I'm just doing a quick recap here. F of x plus h minus f of x all over
H.
h. Yes, good. And this, if you recall, this was the approximation between 2 points. And if you wanted to get a very accurate gradient, you had to close in the distance. So h is the distance between two arbitrary points. And as you're closing the distance, h becomes 0 and the gradient becomes more accurate. Nice. Let's go through a couple of rules quickly. So let's just say we have d dx of x to the power n. How are we going to differentiate this?
N
NX.
nx n minus 1.
Okay. So quick example. Let's just say I had a function z is equal to theta to the power 5. Let me see. Okay, guys, if I have z is equal to theta to the power 5, would I go and write dy dx?
No.
No, sir.
No, we have a function z here changing with respect to what variable?
Theta.
Theta.
Ah, yes, because I hope you all could understand. For a function, don't you plug in inputs?
Yes.
Yeah. If you change the value for theta that you're plugging in, would z change?
Yes, sir.
Yes, sir.
Yeah. If I put 1 into this, z will be equal to 1. If I put 2 into the function, z will be what? What's 2 to the power 5? 2 to the power 5. Calculator. Casio calculator.
3,125.
2 to the power 5?
32. 32.
I
Now I
put
know.
5 to the power 5.
Now I know 32, right? So can you guys see when I change the value of z, I'm gonna say when I change the value of theta, what changes as a result?
Z. Z. New.
Yeah,
Z
yeah.
value.
Over here theta was 1 and I get 1. Over here theta was 2 and what I get?
32.
32.
Right. So the function z changes with respect to the variable.
Theta. Theta.
Good. So when I'm writing this, I'm going to say dz d theta. And again, you're going to apply the exact same rule. It could look a bit different, but it's the same rule. So we're going to multiply by the power. So what would I write?
5 theta to the
5 theta.
power 4. Well, 5 minus 1.
Good. 5 theta to the power 4 because I had minus 1 from the power. Is everybody okay with that?
Yes, sir.
Yes, sir.
Let's do another one quickly. Let's just say we had alpha is equal to beta to the power 7. How would the first derivative look for this? How would the notation look like?
D alpha
D
over
alpha
D
over D
beta.
beta.
All right, d alpha over d beta. And how would that look like?
7 beta 6.
7 beta to the power 6. If there's anybody in class that's confused and they want me to go over it, that's not a problem. I'm here to help you. Just tell me. I will go over everything. Okay. Why would anyone willingly choose to do odd maths? Maths done already hard. Most people in the Caribbean hate maths because the way it's brought across, but maths is actually cool. And a lot of the odd maths people here understand and share that sentiment, right? As well as career paths. Okay, let's look at a slight variation quickly. Let's just say we had d dx, ax to the power n. What would I do here?
NAX.
Yeah, I could say a n x to what power, guys?
N minus 1.
N minus 1. I just scared me, I just here in Virginia, and Virginia, I'm not in Form 5, Virginia in Form 4. She just here for vibes. I want to be here, any people are going to write the exam. You know what I mean? I don't want to be here, any Form 4 person, the one Form 4 person. So let's look at an example quickly. Say, for instance, I had y is equal to 5x squared. One of the Form 5 people, what would the first derivative for this look like?
dy over
dy dx.
dy dx, and how would I differentiate that?
10x
By 5.
10x. Just 10x.
Just 10x. Great. Great. Nice. Say I had t is equal to s squared. How would the first derivative for that look like?
dt over
dt over
ds.
dx.
Dt over ds.
And it'll just be 2s.
2s.
Exactly. Good. Next one. If you had d dx of ax, what would the answer be?
Wouldn't that be minus a? No. That'll be just A. X
That'll just
Fine.
be
No.
that'll just be. And let me give you all a quick example why. Right? Quick example why so you guys will understand. Consider we had a linear function y is equal to 5x. Let's put in some inputs here quickly. When x is equal to 1, what would y be equal to? Tell me fast.
5,
5. When x is 2, what would y be?
10,
10,
When x is 3, what would y be?
15.
15.
Let's look at the rate of change, right? Because that's what differentiation is. Differentiation is just rate of change. So when we increase from 1 to 2, we're increasing the x value by 1. But the y value changes by
By 1,
5.
5.
5, yeah.
From 2 to 3, it goes up by
1,
1.
the y value goes up by.
5.
So what is the rate of change here?
well, 1, 5,
1 and 5?
5. Because to find the rate of change, you would say the change in y over the change in x. So the change in y is 5 and the change in x is what?
1,
1.
What's 5 over 1?
5,
5.
5.
So for any linear function, what you have in front here, the coefficient tells you your rate of change. Because as you could see, this literally tells me whatever x is, y is going to be how much times that.
5,
Exactly. So for any linear function like this, the rate of change is literally in front of your eyes. So the rate of change is just 5 because as you put in different values for x, the y value is just going to change by
5,
5.
exactly. Right? So if I had something like y is equal to 9x, what would dy dx become a fast?
9,
9, right. If y was equal to minus 7x, what would the rate of change be?
-7.
Minus 7.
7.
Good guys. Now we're cooking. Right? So if I have something in the form ax and I differentiate it, it's just going to be a. Let's look at some quick examples. Say give me a letter, random letter, give me a letter, fast. Give me a letter.
V.
I'm going to say 12. Yeah, give me a letter.
R,
V.
R.
Okay, no problem. And let me just say, let me just add in some things here. So like, what if I say 9 plus t squared? I say 9 plus t squared plus t plus 2t. Let me see how you guys gonna handle this.
It'll be
D,
dv over dt
T plus 2.
So dv over
2t
dt
plus 2.
and
T plus 2.
good. I have a question, guys. If I differentiate a constant term, what am I gonna get?
It is this.
Zero.
0.
0.
Now, a lot of you guys don't understand this, you know. A lot of you guys don't understand why. So, let me just explain something so you guys will understand the intuition behind it. I explained this in the other class, but I know a lot of you guys did not watch that. So I have to go back. What would the equation for that line be?
Y is equal to 4.
Because that's a line passing through 4 on the y-axis, so y would be equal to 4. Let's look at what happens for different values of x. Question. Does the output change?
No, sir.
Tell me, guys, when x is 1, where's my answer still?
4.
When
4.
x is 2, where's the answer?
4.
4.
When x is 3, where's the answer?
4. 4.
So wait a minute. So in other words, 4 is staying what? Starts with C. It's staying.
Constant.
Constant.
Whoa! That's why we just call it a constant earlier. So that's why. So what would your rate of change be? Is it changing?
Nope, it'll be 0.
No, it's not changing. So the rate of change is 0. So anytime you find the derivative or the rate of change for any fixed number or any constant, it's going to be 0. Right? Please remember that. So just notice real quickly. ddx of a constant a would just be what?
0.
0.
0. It doesn't matter what number, all numbers are constants. Good? So here what? Differentiation is a linear process, meaning that we could break up this into separate parts and you can differentiate each element separately, independently of each other. So if I differentiate 9, what would that be?
0.
0.
If I differentiate t squared, what would that be?
2t.
50.
T.
If I differentiate 2t, what would that be?
2.
T. 2.
I'll be 2. And for you eagle eye viewers that good in kinematics, you'd realize this is what's dVdt? Change in velocity over change in time. What's that?
Yeah.
Acceleration.
Acceleration.
Acceleration. Yeah, you're good. Because acceleration is just the rate of change of velocity. That's what it is. Okay, good. So let's go on to the rules quickly that I need to know. I only see Nikolai have the camera on, nobody else. I'll leave him hanging, boy. If there's one thing I could rely on my son Nikolai, but I could always rely on my son Nikolai. Always. Nikolai, I gotta adopt you, I gotta adopt you. One of these days I gotta adopt you. Yeah. I joking. Your mommy wouldn't let me adopt you.
Yeah, she said she done just already, so.
All right, so let's look at the rules quickly. Anytime I have a product of two functions, what rule to use? So like say I had y is equal to sine x. Say I had y is equal to sine x by 5 plus x to the power 4. Which rule would I use to differentiate this?
Product rule.
Product.
I would use the product rule. Good. Why am I saying to use the product rule?
You have two products.
Yeah, I have. So I
Is
can, in
there a
other
bracket?
words, I can say that sine x is what? This is hard maths. Yeah, I can say that sine x is what?
A
A
function.
function.
Right? Is a trigonometric function, and I can call that u. And this over here is a what kind of function?
Linear.
Linear.
Linear. V.
No, as a binomial.
Okay.
No.
Okay, I want to
You
say,
know,
right?
that's because of the brackets. So.
That's a
Exponential.
polynomial. Okay, that's a polynomial.
Oh,
That's a
wow.
polynomial. That's a polynomial of degree 4. If you expand that out, you're gonna end up with x by x by x by x. So x to the power 4. With other terms behind. Trillion terms behind. Right? So this is u and this v. Alright? Remember quickly, what does the product rule look like? So d dx uv is equal to what?
U, which
V
is
dv
dv.
over dx plus u dv over dx.
Question. If I write that, or I write this, would both be correct or would one of them be wrong?
Both of them
The
be correct.
correct.
No, I think so.
Both of them are equally correct because addition is what? What is addition? Addition is what?
Commutative.
Commutative.
Commutative. So it doesn't matter if I say v du dx plus u dv dx or any other order. It's fine. It's fine. But the reason why I tell students to learn it like this is because in the quotient rule, which one comes first?
V du dx.
Exactly. And you can't switch it around in the quotient rule because subtraction is not a commutative operation. Right? So let me differentiate this quickly, right? Because again, we looked at this in the last class yesterday, so you should be able to handle it. Right. So quickly, somebody tell me what u is. Fast. What's u?
Sin x.
Sin x.
Right. Tell me fast. What's v?
5
5
plus
plus
x.
x power 4.
Right.
To
5 plus
power.
x to the power 4. Good. We have a function u here changing with respect to a variable x. And so that's going to be what over what?
du
Du
dx.
U
over
over
dx.
dx.
du over dx. Yes. Yes. And if I differentiate sine x, what am I going to get?
Cos
Cos
x.
Plus x.
I got get cosine x. Bam. Over here now, this is going to be the change in v over the change in x. But I have a question for you. Are you guys going to multiply 5 plus x by itself 4 times and then differentiate the thing? Are you have time for that?
No.
No, sir.
So use chain rule. Use shortcut chain rule.
Yes, we have to use the shortcut of the chain rule. For those of you guys that forgot the shortcut, here's what you're going to do. What is my power here?
4.
4. So I'm going to pre-multiply by 4. Then I'm going to differentiate inside. If I differentiate 5 plus x, what would that be?
5. No, 1.
That'll be 1. That'll be 1. Okay, some of you all might be confused, right? Some of you guys might be confused. Here what, right, guys? You're not seeing the coefficient, but what's the coefficient that's understood to be there?
1.
1.
1x, right? So if I differentiate 5, what's that going to turn to?
0.
0.
0.
If I differentiate 1x, what's that going to turn to?
1
1.
plus x.
Nice. Nice. We're cooking. So that'll be 4 by 1. And now we're going to write back what was inside the bracket. So that's going to be 5 plus x. And you're going to take away 1 from the power. And what's it going to turn to on top?
3.
3.
3.
Alex, big up your love, big up your love. Right, so 4 by 1 is 4, and then it's going to be 5 plus x to the power 3. And bam, just like that, we're inside. We're good. We're Gucci. Now we could apply the product rule. So we wanted to find the derivative of, well, to answer the original question, we had the original function was called y. So we have y is equal to this. So when you're ready to do the question, you're not going to say d dx, although you could. The proper thing to do is to say dy over what?
dx.
dx,
Yeah.
Right. Good. And to actually differentiate this, we're going to use this rule over here. So we have v du dx. What is v?
5
5
plus
plus
x to the power 4.
power 4.
Good. And then we're going to multiply that by du dx. What is du dx?
Cos x.
Cos x. Mm-hmm. And then we have plus u dv dx. What is u?
Sin x.
Sin x.
Right? It's all straightforward, that matters. It's not like,
Yes,
again,
sir.
I'll call back a cake question, a cookie question. None of that kind of thinking in hard maths, boy. dv dx is, well, we should have simplified this, right? But we know 4 by 1 is what? It's 4 by 1. Oh, we did simplify it right here. Right here. So what is dv dx?
4 in brackets 5x. Well, 5 plus x to the power 3.
Are you confused or you with me so far? Are you all with me so far?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Hey, just because people saying yes, that don't mean you had to say yes, and that don't mean I'm not gonna stop and explain it back to you. Alright, so don't be scared. Alright, we're going. It's a lot of hours today. How more people here? So we go in. Right, we go in, right? We go in. This is just going to be cosine x by 5 plus x to the power 4. I have a question, right? Some people might think to multiply cosine x by, could we do that? That legal?
No, sir.
No, sir.
No, that's not legal. Because if you realize we have 5 plus x to the power 4, you'd have to expand that. You'd have to expand that quartic equation, well, that quartic expression, and then distribute the cos x across it. Do you want to expand this in the exam? You want to do
That's
that?
how much time going there, sir.
No, you're not gonna do that, right? You're gonna leave it as is, and this is you're gonna leave that. And then we have sine x by 4 by 5 plus x to the power 3. So I could just write that as what?
4 sin x.
I could write that as 4 sine x by
5 plus x to the power 3.
Are you guys seeing anything I could potentially factor out between
Yes,
those
sir,
two
the
terms?
5x. The 5 plus x, whatever.
So I have a 5 plus x to the power 4 here, and I have a 5 plus x to the power 3 here.
5 plus x
what's
to
in
the third.
5 plus x to the power 3.
Or 3.
Good. Good. You can't pull out 4, right? Because where you get the fourth one from here? You know what I mean? You have to pull out 3. Because you have in 4 you have 3 and another one, and over here you have 3 as well. So you can pull out 3. Then inside I'll say cosine x by what? I had to say cosine x by what?
5 plus
5
x.
plus x.
Well, no, it's just 5 plus x.
Right? And then I'll say plus what?
4 sin x.
4 sin x.
Are they okay with this question?
Yes, sir.
Yes, sir.
It's gonna be like a little 4 marks in the exam, like a cool 4 marks in the exam. Yeah? Alright, let's move on to quotient rule fast. Do a quotient rule example. So quotient, if product was a product of two functions, which thing quotient rule is?
The subtraction and division.
Right, division, right? Division. So somebody tell me the quotient rule fast. It'll be d dx u over v is equal to what?
Same. What?
V square.
Wouldn't it be the
U
same thing as the
dv.
product rule, but just divided by v squared? So it'll just be v u over dx
dx minus
minus u
u dv
dv over
dx
dx divided by v squared.
upon v square.
Bam. Let me do a quick example. Let's consider cosine x all over 3 plus x. Easy example. Tell me guys quickly, what is u and what is v? What would u and b? What would u be and what
With
would v?
cos x and 3 plus
Cos
x
x.
is v.
This is u and this is v. So therefore, I'll say u is equal to what?
Cos x.
I'd say v is equal to.
3 plus x.
I'll make this example real simple for you guys. We're gonna differentiate what with respect to what here.
U in respect
U
of
with
cos
respect to
x.
x.
U with respect to x. Nikolai, we don't look at the function per se, we look at the variables. Because the variables, remember Nikolai, this is our function. And what could change here in the function?
The x.
Exactly, the x. So the function is changing with respect to x, so du dx. If I differentiate cosine x, what would that be?
Sin x.
Minus sin
Minus
x.
sin x.
Minus sin x.
Careful, guys, that's minus sin x. Over here, I'm differentiating what with respect to what?
V
Out
with
of the
respect
x.
to
v upon dx.
Right. If we could, I want to finish in differentiation and integration today, and hopefully you can move on to kinematics, because kinematics is the natural order of progression with this. dv dx. If I differentiate 3 plus x, what am I going to get?
X.
1.
1.
1.
Take your time, Nikolai. Take your time. So, Nikolai, watch. I know you're not seeing it, right? But what is the understood coefficient here?
1.
1x. If I differentiate 3, what would that turn to?
Turn to 0.
If I differentiate 1x, what will that turn to?
The 1.
Exactly. Exactly. So that's 1. So now, notice that in this question, did you see that this was equal to anything?
No, sir.
No, sir.
No. So then we're just going to write d dx, whatever the expression was. So d dx cosine x over 3 plus x, and speed. That'll be what by what? Tell me, what's v?
3 plus x.
Right? Right, quickly, what's du dx?
Minus sin x.
Minus sin x.
Right? Where's u?
Cos
Cos
x.
Cos
x.
x.
What is dv dx?
1.
1.
1.
Oh, let's see how easy I make this example for you. Real easy, man. And where's
Sir.
v? Where's v?
The
3
3
plus
plus x.
x
We add
squared.
to square.
All square.
If you write if you do that, that's legal. If you do that, that's legal.
No, that's not legal. It just be the x squared and not 3.
Square only governs x in that situation.
Let me explain something, guys. Is v just x or is it 3 plus x?
3 plus
3
x.
plus
3
x.
plus
3 plus x.
Exactly. If I were to square the x alone, I'll be squaring x alone, not the entire thing, which is v. I want to say v squared. So I'll say 3 plus x in brackets, because this whole thing represents what? What does 3 plus x represent?
V.
V.
Yeah. Here what then? I'm gonna tell you this. I'll see a lot of people asking for predictions on it. I can't predict anything on it. All I could do is just teach all the work. So if it does come, I'll get all the marks. That's what I could do. Alright? I don't work in CXC headquarters. I don't know nobody. I just teach all the work I can teach all it.
Must say you
Right.
predict the teeth in biology. Alright.
I feel like I'm a low-key pretty physics. Anyways. Over here, is this a situation where we could expand?
Yes.
Yeah, we could expand this. So we could say minus sin x by 3. And we could say minus sin x by...
X.
X.
If I expand that, what's gonna happen?
Minus 3x. Minus 3 sin x.
Right, let me explain a mistake some students make. Some of they go say x by x and write minus sin x squared. Are they gonna do that?
Yeah, what I got.
Where x?
Let me explain something, guys. Sine is an example of a what? Sine is an example of a what?
Trigonometric function.
Yes, if you didn't know, sine is an example of a function. What is inside the function right now?
X.
X.
X is inside the function. If x is inside the function, we could do anything with our x?
No.
Nah.
No.
No, that x in a relationship.
Leave that x right there.
Leave that x right there. Move on, all the other move on. We gotta take the advice from Nikolai. You know Nikolai had real x's, he real moving on fast.
So I jump in, sir. I jump in.
Hey, what? Wait, all you hear Nikolai just now, man say he jumping, boy. Man say he jumping. That's crazy.
Yeah, what
That's
the X
crazy.
give me? Is like I jumping from X to X.
Hey boy, that's crazy. Nikolai bad, eh? Hey, that's in a good way. And well, that'll just be minus cosine x because cosine x by 1 is just cosine x. Cool. Um, we can't really do much there. I mean, if you did once, you could factor out the sine x and write sine x by minus 3 minus x. But really, this is fine. This is fine. That was easy or hard?
There was no more, so.
All I think that was
I
easy
would
or that
have
was
been
hard.
thinking about expanding the brackets, but then it would have still been the same thing. Because they can't do
Yeah.
anything. So.
You can't really do anything. That's fine there. That's fine there. Right, cool. That's fine there. All right, let's move on to chain rule now. I love chain rule, Ollie. I love chain rule. Chain rule is goated. So when do you use chain rule? You use it anytime you want to connect different rates of change. You'll see what I mean just now.
So just something to say. I only know how the product rule would have been in effect is when it would have been more than the power of 2. I didn't know it was supposed to be in brackets as well.
Oh, yeah, yeah. Because if something is more than to the power 2, then it's very impractical to expand. All right. And some people would also know that you use chain rule when you have a function within a function. And I hear Mikhail at all today, boy. Hey, Mikhail, what going on there, boy? I ain't even seen your camera on, boy. Mikhail, boy.
So my camera,
Yeah.
I was talking and answering all the time.
Oh, I'm not seeing you. I don't know what Zoom doing, but I'm not seeing you.
Probably
Right?
internet. So.
No, no. Hey, I have three. Let me explain something, Mikhail. Right now, I get in 400 megabytes per second, 5 milliseconds ping. It can't be no internet thing, boy. Can't be no internet thing. I upgrade my internet. I put your router right on my laptop and right here. No internet thing. Right?
You
So,
have to flex your internet speed. Alright.
hey, before I was getting 60 megabytes per second, no, but see, when I helping all the other doing lives on thing, I can't afford no internet problems. I had to fix that. I had to fix that one time. So I went and fixed it one time. All right. So say you had y is equal to something like minus sine 7x, right? Is sine 7x something you would typically differentiate?
No, sir.
No. But guys, but if I had something like y is equal to sine x, could I easily differentiate this, guys?
Yeah.
Yeah.
Because just because
Yeah. It's just because x. A little bit more now. If I had sine x, and that would just turn to cos x.
Yes, sir.
Yes, sir.
Okay. I only hearing a few people. I don't know what this silence is about. If I had y was equal to minus sine x and I differentiate that, what would that be?
Minus cos
Minus
x.
cos
Minus
x.
cos x.
That's all. It would just be minus cosine x. No tricks. I promise, no tricks. No tricks. So let's move on. So, the question. Let's stay with me, right? If differentiating sine x is not a problem, and differentiating minus sine x is not a problem, what do you feel causing any trouble over here, Olia?
That's
The
seven.
9x,
7x.
and the 7x.
This 7x causing real bacchanal, boy. Hey, it's like Nikolai in Romano relationship, boy. Nikolai, remember how we take the man, take the man, girl?
Yes,
Hey,
sir. Yes, sir.
man say yes to way, boy. Hey, match vibes low intensifies. Right, so here's what. We're gonna say let u be equal to what? What
7x.
caused any trouble?
9
Yeah,
minus.
7x.
we could say let u be equal to 7x. A 7x is what's causing any trouble. If I tell you that u is 7x, instead of writing minus sine 7x, what are you going to write instead?
Minus sine.
Minus sine u.
Minus sine u.
Oh, and is this something we could easily differentiate now?
Yes, sir.
Yes, sir.
Yes, sir.
Yes. Is this something we could easily differentiate?
Yes, sir.
Yes, sir.
Yes, sir.
Yes. So we're going to differentiate the function u with respect to x here. So we're going to say what are we going to say here?
That could be 7.
d over
Or d
d
over
over
dx.
dx equals
I'm gonna
7.
just be 7.
7.
Right. And over here we're differentiating the function y with respect to
U.
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 right. If I differentiate that, what I'll be?
Minus cos.
Minus
Cos u.
u.
The cosine.
Cos u, yeah.
Don't let the variables confuse you. Don't let the variables confuse you. We know this. We know how to do this. Right? Minus cosine u. Good. Now let me ask you a question. In the original equation, we had a function y changing with respect to what?
X.
7x.
X. So, what we really wanted to find was dy dx, and
Yes, sir.
Yeah.
but we say like, nah boy, this 7x causing trouble. So here's what we're going to do. We need to connect the different rates of change. Can you guys see that we have this rate of change and we have this rate of change?
Yes, sir.
Yes, sir.
Now we are going to try to connect that and get back dy dx. Now let me explain something earlier. Let me explain something. If you do higher level maths, you'll see you can't really treat it as fractions, but for add maths level, we could treat it as fractions. I have a question, right? Again, if we're treating this as fractions, what would have to come over here?
dy
dy.
And what would have to come over here?
dx.
Yes.
And you would need to have some other variable
I
here.
cancel.
Oh, and
Yeah.
when you zoom out, oh, let's see, am I seeing?
Yes, sir.
du
Yes,
Yes,
and
sir.
du.
dy over du and what?
du over
du
dx.
over
The
dx.
DX.
That's legendary, right? So we have dy over du and we have du over dx. So the chain rule is used to connect different rates of change. What is dy du?
dy over du is minus cos u.
Oh yeah, I gotta put that in brackets, right? To be safe. Because I know one earlier might put by 7, and you know what you gonna do in the next line? You know what you gonna do? You go say minus cosine 7u. That legal?
Nah.
Yeah.
That's not legal because u is within a trigonometric function, and so you can't do anything with it. And so what you need to do is put it in brackets so you don't make that mistake. And where's du dx?
7.
7.
7
So what would the next line look like?
Negative 7
minus
cos u.
7 cos
7
u.
cos u.
But in the original question, we had y changing with respect to what?
x.
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 However, we have what we have here.
U. So we had
U.
to x.
Yeah, we had to change our u to what?
7x.
7x.
Right. Now here we're saying if they give you a standalone question like this and it's worth like 5 marks, you can't use a shortcut. However, if it's within a product rule question like this, are you going to do the full thing or are you going to use a shortcut?
Shortcut, sir.
Shortcut. Understand what I'm saying? If you have chain rule in a much bigger question, what are we gonna do? Shortcut or full method?
Repeat.
Full method.
Wait, now hear what I'm saying, right? If you have chain rule in a much bigger question like this, you can do the full thing or shortcut.
Shortcut.
Shortcut. If you have a standalone question, meaning it by itself, shortcut or full thing.
Full thing.
Full
Full
thing.
thing.
Right. Let me just show you guys the shortcut quickly. So we originally had y is equal to minus sine 7x, right? Here's what you're gonna do. If you differentiate the inside the brackets, what you get?
7.
7.
Yeah, 7.
So I'm past 7 on the outside. If I differentiate sine, what I get?
Minus cos.
Minus cos.
Negative cos.
No. If you differentiate sine, you get positive cos.
Doesn't cost you.
Yeah, and I'm gonna write backwards on the inside. Then we could just multiply with 7. Yeah, with 7 by negative 1. That'll be negative 7. Yeah, are you understand?
Yes, sir, but one question, sir. So you put the u by the 7x. Could you have to put it by this minus sign?
Yeah, wait, you mean like over here?
No. For the when we start off with the differentiation, sir. No, for the problem. The problem where you put u, the minus sine 7x, and you put u underneath the 7x.
So we let u be equal to 7x because that was the one causing the trouble.
Also, because you had to put it over there. You did. What I was
Yeah.
asking is if you could choose either or, like if you could have put u underneath the sign.
You mean like over here?
No, you put that for the 7x, but I'm asking if you put the u underneath the sign, the minus sign.
Nah.
Right.
Nah, you can't do that. Can't do that. Right? Let me see. Let me test you guys quickly with the hack. Consider I had a function y is equal to minus 3 cosine 10x. Well, if I differentiate that, what's the first thing we're gonna do?
The 10x,
10x.
It's
If I differentiate 10x, what that would be?
10.
10.
10.
So I got 10 on the outside, right? I got to write back the minus 3. If I differentiate cosine, what would that be?
Sign.
Sign.
Negative,
Let's see
Minus
equal to
sign.
negative
that's
sign.
sign. Negative sign. Right, negative sign. And I'm gonna write back the 10x. Ooh, it's like I'm using a sharp calculator here, buddy. I want that brackets I put in. And so you don't have to do all of this here by showing this because this is full working. So we have a negative and negative. It was a negative and negative.
positive.
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 Say a positive 3 by 10. What's positive 3 by 10?
30.
Right? So that'll be 30 sine what?
10x.
Obviously, you didn't have to do all of this, you know. You didn't have to do all of this. Like, watch. When you look at this, right? You know the 10 here going to multiply by the minus 3. So you know it's going to turn to what?
Minus 30.
Negative 30.
And you know that when you if differentiate cosine is going to turn to what?
Minus sign.
Minus sign.
So your answer is just 30 sine 10x. That how that easy.
Easy.
I think that easy. I think I can get that for sure. For sure. For sure. Right? Okay. When else do you use the chain rule? Consider you had a problem like y is equal to the cube root of x plus 7. Is that something you would typically differentiate?
No.
No,
No,
sir.
sir.
Nah. Let me ask you a question though. If I had something like y is equal to x to the power a third, would that be hard to differentiate or easy to differentiate?
Nah, easy, sir.
Easy.
Easy.
What would the answer be as a matter of fact?
Maybe 1/3
One
minus.
zero.
Well, 1/3 x minus 2 to the power 3.
Yeah,
2/3. Yeah.
that's
Yeah.
correct. So that really easy to differentiate and that really easy to differentiate. Now here what I'm saying, we could rewrite this. If you recall the laws for indices, the cube root is the same thing as to what power? What
1
power?
over 3.
Negative 3.
1
Negative
over 3.
3.
Non-negative, 1 over 3. And we use negative powers to indicate fractions, right? So that'll be x plus 7 to what power?
1/3.
1/3.
So I want to let's do a little comparison here. A little comparison. This easy, right?
Yes, sir.
Yes.
This easy?
Yeah.
Yes, sir.
Well, yeah, it's easy now. I don't know what to do, right? But which one is objectively easier? 1 or 2?
1
1.
1.
So what let's cause any trouble over here?
is x.
7.
X plus 7.
The x plus 7. So you don't know what we're going to do, right? We're going to do a u substitution. We're going to say let u be equal to what?
X plus 7.
Plus
X plus
7.
7.
Yeah, we can say let u be equal to x plus 7. And if I say that, my function for y now becomes y is equal to.
U to the
U
power
to the
1/3.
1/3.
Let me ask you that question. This hard to differentiate?
No.
No, sir.
Is this
No.
hard to differentiate?
No, sir.
No, sir.
No,
No,
sir.
sir.
No. Well, you'll have two different rates of change, and to connect them, you'll use chain rule, which is the product of two other rates of change. So quickly, this will be du dx. So what would the answer be, Nikolai?
1.
1. Oh, okay. Then we have dy du. Anya, what's the answer? It's Anya here. Oh, I have Anya here, boy.
Sleeping.
Anya real smart, you know. She should even have to be here. Yeah. Yeah, I don't think she's here, but she real smart. She don't have to be here. Real smart. If you differentiate that, what do you get, guys?
1/3
1/3 U to the minus 2 upon
1/3
3.
u minus 2 to the power 3. Well, difference. My bad.
Right, cool. And so we'd combine this, so it's dy dx. And dy dx would be equal to what?
That is
1/3
one
u
third into
to the
1 to the minus
negative
2 upon
power
3.
2/3.
But let's take your time, guys. You have to write the chain rule parts. You have to say dy du by
Minus
dx.
dx.
Right. Dy du. That part is a third u to the power negative 2 over 3. And du dx is 1. Yeah? Du dx is 1.
Yes, sir.
Yes, sir.
If any of you all are confused as to how we got the negative 2 over 3, what is that third minus 1?
On
Negative 2/3.
Correct. Negative 2/3. Yeah. And well, this will just produce 1 over 3 u to the power negative 2 over 3. Again, can we leave our final answer in terms of u?
No, sir. You got to replace it to the x, which would
Nah, I'll
be
have to replace it.
wouldn't
How
that
is u? What do
be
we say u
x
was?
plus 7?
Yep, we said x plus 7. Now, if you leave your answer like this is fine, but you could also write it as a cube root and thing. You could say you could say 1 over 3 cube root of x plus 7 squared. But I might lose a lot of you guys if I write it like that. But I should still show it. You'll need to know indices. Again, if you have negative powers, it usually indicates what?
Fraction.
Root.
Fractions. Fractions. So here what, right? Here was the case, guys. Consider I had a to the power negative n. Another way I could rewrite this is a to the power negative n over what?
1.
Over 1. So the power is negative in the numerator. So where could I send it?
To the
Okay.
denominator.
So,
If I send it there, it's going to become 1 all over 1 multiplied by a to what power?
And
The n.
Good. Let's apply the same rule over here. So we have x plus 7 to the power negative 2 over 3. I could rewrite this as x plus 7 to the power minus 2 over 3 over 1. So if you send that to the denominator, it's just going to be 1 over 3 by x plus 7 to what power?
2/3.
The 2/3.
Good. Now, what exactly does 2/3 mean? Do you all remember that's our power? It's our
root
power.
of-
If you have a power, it's our power, right? What happens with the powers?
The
Now, let me explain. Consider you had en to the power m.
how they multiply.
Then multiply.
It could
Yeah,
be e
multiply.
and m.
Good. They multiply. And so consider for a second that you had a to the power 2 over 3. Another way I could rewrite this, I could say a to the power a third raised to what power?
2.
2. Or consequently, I could also say a to the power 2 raised to what power?
A third.
Right, because multiplication is
Commutative.
are you understand?
Yes, sir.
Yes, sir.
So here what I'm saying, right? Here what I'm saying, guys. Here's what I'm saying. Stick with me. You see this x plus 7 to the power 2/3?
Yes, sir.
Another way I could rewrite that is okay, so you understand what I'm saying here, right?
Yes, sir.
Yes, sir.
Kind of. Okay, let me run it back again. So a power to a power means you're doing what's with the powers. Yeah, if you
Multiply.
want to join the Zoom meeting, just send me a message via WhatsApp. My number all over the place. Just find my number, message me, and have a parent that are interested in our idea. Yeah. What's up? If you have a power to a power, what do you do the powers?
Multiply.
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 You multiply the powers. Good. And so if you have a to the power 2/3, another way I could rewrite that is a to the power 2 raised to what power?
A third.
1/3.
And something to the power a third means the exact same thing as what? What do you mean?
Cube root.
Cube root.
Cube roots. So I could write that as the cube root of what?
A
A squared.
A squared.
Good. Let's apply that exact same concept to what we have here. So that's going to turn to 3 multiplied by the what roots
Cube root.
Cube root.
Cube root.
of x plus 7 to what power?
2.
Square.
Badness. Big up for your whole self for that. Big up for your whole self. Yeah. How you feeling about that? Feeling good?
Yes, sir.
Yes, sir.
Yes, sir.
Kind of. Somebody said kind of. So if you're saying kind of, talk to me, let me know which part confusing, yeah? And I will go over the whole thing if you need me to. It's not a problem. So this is the whole concept of chain rule. Yeah. And you typically use it when you have like a function within a function. Or in other words, something unlike ungodly to deal with. Like something really tough to deal with. People on TikTok, this is hard maths, eh? We're doing calculus right now. This is calculus. This is not regular maths. How fast do you think the average student could learn hard maths? Well, if you have a strong foundation in maths, probably wouldn't take that long. But if your foundation in maths kind of crumbly, it could take real long. Because you have to correct your math foundation first, and then do hard maths. Yeah. All right. So we went through. So, Mikhail, we essentially ran through everything we did in last class in like an hour. Yeah, like essentially an hour. Like we started at 6:16 and it's 7:16 now. Mikhail, you good?
Yes,
I
sir.
left Mikhail still here, boy. Trying to open this drink, but
in
it's so hard
his
to
Zoom,
open.
but you know, responding.
Well, you don't know, these classes interactive. I don't hear any of them.
Yes, I
They're
hear.
moving real dead, boy. Real dead. How about your exam? I take exam mash all up, boy.
No, no, no.
No.
I don't know about the rest of them. Probably.
I don't know. So long story short, you use the chain rule anytime you have something kind of hard to deal with. You have to make a substitution. Let's run through some cases quickly. Guys, would I use chain rule for something like this?
Nah.
No.
No.
No, because and you can expand that out and then differentiate.
Yes, sir.
Yes, sir.
Yeah, would I use chain rule for something like minus x plus 7 to the power 3?
Yes.
Yeah.
Yeah, do you
Yeah.
want to sit down in the exam and multiply minus x plus 7 by itself 3 times?
No, sir. Too much work.
Too much work. So somebody said they wanted me to go back through the chain rule. Let's do an example quickly. Right, so the first step, what we're going to say let u be. What caused any trouble here? What caused any trouble here? What caused any
X
back
plus
and up?
7.
Minus x
X
plus
Negative
7.
x plus 7.
Right, so we're going to say let u be equal to minus x plus 7. And if we say u is equal to minus x plus 7, then y is going to become what?
U
U
cubed.
to the power 3.
Right, good. So we're going to differentiate the function u here with respect to the variable what?
X.
Right, what's that going to become? Tell me fast, guys.
Negative 1.
1 negative
Minus 1.
Minus 1. Over here, we're differentiating y with respect to?
Three
U.
U
U.
So that'll be what?
3
Three
U.
U squared.
squared.
3u squared. Good. Nice. Then we're going to use chain rule to get what? What did we originally want to find for? Originally,
Y.
Y over dx.
dy over dx. So we need to use the chain rule to connect the different rates of change. So I'll say what two things by each other? What two things I'll
dy
say?
over du
U.
times u over dx.
Good. What's dy over du?
3u
Three
squared.
U squared.
3u squared. Bam. What's du over dx?
Negative
Negative
1.
1.
Right? When you multiply that out, it's going to be negative 3 u squared. We can't leave u there because it's dy over dx. So I need to replace u with what?
Negative
X
x plus
plus
7.
7.
Good. That's it. That's it. Easy peasy lemon squeezy. Now, let me look at the shortcut, right? The shortcut real simple. So if I wanted to differentiate this, I would pre-multiply by 3. So I'm going to put 3 where?
In front.
In front of the
Front.
brackets.
Alright, then we differentiate the inside. If we differentiate the inside, what will happen?
It will be minus
Negative
1.
1.
Right? Then I write back the inside and what we do the powers? On the power.
Minus the power.
That is it here, no? That is it there. We in business. Minus 3 minus x plus 7 to the power 2. Isn't
So
that the
that's
same
what I
answer?
thought. Then I say, I can differentiate it easy.
Hear what, right, Nikolai? If you get a question like this, a standalone question, and you see it's 4 marks, this is not going to cut it. You're not going to get full marks. Yes,
Yeah.
Christopher, that's correct. Derivative of the inner function times the outer. So when I was talking about chain rule, I say you typically use chain rule anytime you have a function within a function. That's correct. Yeah. All right. Cool. Um, and when you find the first derivative, you find any gradient of the what again? Tangent or the normal?
Tangent.
Tangent, sir.
Right. What's the equation of a line?
Y2
Y
minus
equal
y1
mx.
over
Oh,
x2 minus x1.
I talking about gradient then Nikolai. I'm talking about the equation of a
Oh,
line.
oh, the
Y
equation.
equals
y
mx
equal
plus
mx
y
plus c.
equals mx plus c.
Well, let me tackle a couple of those questions.
So,
As soon as I
so one more question, right? Isn't the y minus y1 also the gradient, but that relates to the point as well?
oh that equation of the line is called the slope point formula as a slope point form. As a
Right.
slope, they call it the slope point form because it uses a point and a slope and a slope. Right? The y is equal to mx plus c is called the slope intercept form. And then you have ax plus by plus cx is equal to 0, which is the standard form. But the easiest one to use by far is y is equal to mx plus c. Trust.
Oh, okay.
Well, I want to tackle this question. I think I can do it.
Sure.
I hope so.
Yeah.
Let me see that. Let me do that fast. Like real fast. To do this question is a combination of what two things. Someone fast.
Product and chain.
Product and
Chain
chain
rule and
rule.
product rule.
Product and chain rule, right? Because I have 2x multiplied by this other function over here.
Yes, sir.
Okay. Right. So here what? Remind me, what is the product rule?
V, well, it's supposed to be UV, which is equal to V, which is du over dx, plus U, which is dV over dx.
Okay. What would u be and what would v be?
U would be 2x and V would be 4 minus 8x. The
Nah.
square root of 4 minus 8x.
Right? What would the udx be?
2.
Cool. What before we do any differentiation, we need to rewrite this as 4 minus 8x to what power?
A half.
Uh-huh.
Seeing that this question is within a much larger question, we're going to use the shortcut version of the chain rule. So we're just going to say dv dx.
Which is
Um,
a half multiplied by negative 8. And we put back in the stuff, which is 4 minus 8x.
What power?
The minus, no,
Minus a half, right? Because a half minus 1, a half minus 1 is negative half, right?
Yep.
Yeah or no? I'll understand that, right? A half
Yes,
minus
sir.
1 is negative a half.
Yes, sir.
What's a half by negative 8?
Negative 4.
Negative 4.
4.
People on TikTok, if you're interested in joining the Zoom meetings, it's free. Just message me on WhatsApp, have appearance and a voice note, confirming you're serious, and I'll add you. Right? Nasya, but say your name correct. Cool. So to find my answer now, which is dy dx, I would say what by what?
V multiplied by d over d. Well, I had to put in the UV.
No, because watch, look at the original question. The original question stated that y was equal to this. So when you're differentiating, what will you say? Will you say d dx or will you say dy dx?
dy dx.
Right, because it's y is equal to that. And so it's v du dx. So what was v again?
V was the square root of 4 minus 8x.
Cool, what was du dx?
Was 2.
Right, that was 2. Are you all going to multiply everything here by 2?
No.
Anybody? Would any of you guys multiply 4 minus 8x by 2? Would you all do that?
No.
Nope.
No, because 4 minus 8x is within the square root function. I can't do anything with it, right? And then we have plus u dv dx. We have u is 2x.
Yes, sir.
And what is dv dx?
Minus 4 in brackets 4 minus 8x to the power of negative a half.
Right, so what is this going to become? How should I write this?
Would you change the square root to the power of half?
Nah. You typically leave your answer in surd form.
Okay.
2 square root 4 minus 8x.
Right? And what is 2x by negative 4?
Minus 8x.
Minus 8x, yeah. And we're multiplying that by 4 minus 8x to the power negative a half. Now, we spoke about negative powers, right? Negative powers are indicative of what? Oh, wait. Somebody said they want me to go over the negative a half part. So, edits. Let me ask you a question. So, when you're doing the shorthand version of the chain rule, you're going to multiply by the power. So, you have a half here. Then you differentiate the inside. If I differentiate 4, that's going to be 0. If I differentiate minus 8x, that's going to be minus 8. So, I get half by minus 8. Then I write back this, and I minus 1 from the power. So, like, what's a half minus 1? What's a half minus 1?
Minus a half.
Negative
My
minus a half. And that's how I get the negative a half. Right? We spoke about negative powers. Negative powers are indicative of what?
Fraction or
Positive
reciprocal value.
Fractions, right? Fractions. So I'll say minus 8x all over what?
Square root of 4 negative 8x.
Yep. If you're confused, right? Understand something. If you send 4 minus 8x to the power negative a half to the denominator, it's going to turn to 4 minus 8x to the power positive a half. And we know that something to the power of positive a half is just what?
The square root.
Just square root. Right, so is everybody okay with this?
Sure, yes, sir.
Yes, sir.
Yes, sir, but for the part we have square root 4 take away 8x, you take out the brackets. That is a normal thing, or?
The brackets are just there to indicate multiplication. Like this. So I'm gonna explain something. What is 2x by negative 4?
Negative 8.
Right? So we can get rid of brackets then because we multiplied the 2x by the negative 4. So negative 8x. You can't remove these brackets though, because these brackets indicate that you're raising this whole thing to the power negative a half. So 2x by negative 4, negative 8x. I write this back.
No, the front part by the square root part I'm talking about.
Over here.
The other part, the front. V. Yeah.
All right. So you don't have to put brackets. The only reason I put brackets over here is so that you don't do a oopsie and say that 8 minus 16x, because I'll be wrong. You understand
No,
what I
the
mean?
4 take away x was in brackets and I take it out. I just want to know why if like it's okay to take it out.
I'm trying to understand which specific part you're talking about.
The question come with square root bracket 4 take away 8x.
Oh,
You take out the bracket.
you don't have you don't have to consider the brackets because like the brackets over here are just telling you that your square root in the entire thing. If I have the square root of 4 minus 8x, it means the exact same thing. And let me show you, so you believe me. Watch, check this, right? Check this. Give it the virtual calculator sometime. Sometimes it's be dead. Give me a second. Are you alive?
He's dead.
Somebody had to explain the science behind this, you know?
Too much maths, sir. Too much maths and maths.
Okay, come on. Right, so Priyanka, that's you.
Yeah.
Alright, check this, right? Open bracket 16 plus 9 close bracket. What's the answer?
5.
Okay. What's the answer?
Okay, so it's also 5.
Doesn't matter, right? Once the whole thing is inside the square root function, then you're square rooting that entire thing. You don't have to put brackets.
Okay.
You understand or not?
Yeah, I understand. I just was making sure, like, if it's needed to be there.
Oh no, I don't need to be there. If they brought the question and they had something like this, you understand how they put the brackets there so you know you're square rooting the entire thing, right? So you see something like this really means, if you understand what I mean.
Yeah.
If you ever use a sharp, you'd realize that the sharp calculator is just like the square root only covers like 1, 2. And square root the entire thing, you have to put the entire thing in brackets. Do you use a sharp or a Casio?
Casio.
Oh well, you don't have to worry about them issues then. Yeah, but anyways, let me continue. Um all right, let me do this question here. 5-mark question. After this, I want to move on to stationary points and nature of turning points.
I
Because
know.
yes. Yeah. All right, let me tackle this question now. Any volunteers?
Yeah, sir. I don't mind.
Yeah, Mikael, give it a read.
The equation of a curve is given by y equals in brackets 5x squared minus 7 bracket to the power of 4. Determine the equation of the gradient of the curve.
Mikael, when a lot of students read this, they're gonna be like, what exactly are they asking for? But we know that the first derivative, what does the first derivative mean?
The gradient function.
Exactly. So all we have to do is find
Gradient function. Or the first derivative.
the first derivative, yes. So that's all. That is all. It's really easy, you know. And since it's a standalone question, are we going to do the shortcut version of chain rule or the whole thing?
The whole thing, sir.
Yeah, look how much marks this is. You feel like doing the shortcut will give it a 5 marks?
Nah, sir.
Nah. Alright, so everybody in class, do you all understand that if you see equation of the gradient, they're asking you to find the first derivative. Do you all understand that?
Yeah.
Nikolai, you see that
Realize
kind of unsure.
no, like I realized that they could ask it in many different ways and you'll have to figure it out.
Yeah. So you could know how to differentiate and not be able to answer the question because you don't understand what it means.
Yes, sir.
So y is equal to 5x squared minus 4 to the what's
It's
in boy?
7, so it's 7.
Yeah, power 4. Okay. So Michael, what causing real problems over here, boy? What causing bacchanal?
The 5x squared minus 7.
Yeah, the 5x squared is causing a lot of problems. So we're going to say let u be equal to
5x squared minus 7.
and we'll say that y is now what?
U to the power of 4.
And so what would I write here?
Du over dx.
And du over dx would be equal to what?
10x.
Guys, if I differentiate minus 7, what's that going to turn to?
0.
0.
0.
0, right? That's going to be 0. Over here, I'm going to differentiate what with respect to what?
Dy over du.
What's that going to turn to?
That'll be 4u to the power 3.
Yeah, everybody with me on that?
Yes,
Wait,
sir.
2.
All right, cool. So we need to find for dy dx, right? That was what the question originally asked for. So now I need to use the chain rule. So how would I connect dy? How would I connect du dx and dy du? Tell me, Mikhail.
So using the way you had say on the top, we had to get dy, so you put dy on top. And then it will be multiply, and on the bottom, we need dx.
All right, so
And
look
now
at
we
the
look on
question.
top. So it will be du and du over dx.
Cool. What's the u? What's the y over the u?
And that is 4u cubed. And that is 10x.
All right, what is 4 by 10?
40.
Right,
The
I can say
40x.
40x.
Yeah.
And we need to recall what u cube was. I mean, what was u? We need to recall what u was. What was u?
U was 5x squared minus 7.
So we say 5x squared minus 7. So what
To the
power?
power of 3.
That's all. And if you had used a shortcut, then it would also work out, but you wouldn't get full marks. So you'd say 4. Differentiate the inside. If you differentiate 5x squared, what would that turn to?
It'll be 10x.
All right, then I'd write back 5x squared minus 7. And the final answer will be 40x by 5x squared minus 7 for a 3, which is the answer we got. Let me know if you all are okay with the question.
Yes, sir.
So your final answer is just dy dx. I notice the odd maths people are a lot more serious than the maths people. Like, they never had no time to play around and think the odd maths people locked in. And I think I'll like get our 5 marks in the exam.
Yeah.
Yes.
Yes.
All right, nice. I think y'all could get it as well. Okay, that is it. Let's move on to stationary points now. Now, at a stationary point, what do you suppose the gradient is?
0. Because it's
Zero.
stationary. Literally say stationary.
Exactly. So dy dx would be equal to what?
0.
0.
Everybody okay with that, right?
Yes, sir.
Yes, sir.
Um, all right, for quadratics, we know that a quadratic could either look like this or it could look like, so that's a frown. It could also look like a what?
That's smiley face.
Smiley face.
Right. How much stationary points do you think a quadratic has?
1.
1.
1. If you're not seeing it, let me explain something. Watch, you're going up, you're going up, you're going up, you're going up. Stop. Going down, going down, going down. Can we identify that this is the stationary point?
Yes, sir.
Right?
Yes, sir.
And if you draw a tangent at this point, you'd realize it's what kind of line? A vertical line, a horizontal line.
No, horizontal.
Horizontal line.
Horizontal.
And if it's perfectly horizontal, what's the gradient?
0.
0.
I'm blowing my mind. Wait. Stay with me. Remember the start of class. I draw this?
Yes, sir.
Yeah. I tell you that was what?
A constant.
Constant.
And the gradient was 0.
Yes, sir.
Everything is connected on there. Everything is connected. Same thing over here. The gradient here would be what?
0.
0.
Yeah, because it's a horizontal line. All right. So quadratics, they have one stationary point. All right, let's look at cubics. So generally speaking, it's what a cubic does look like. Did you all know that?
Yeah, I remember
Yeah.
that from me
Yeah.
last time.
Okay, good. Better. We'll take that, right? How many stationary points are you all seeing?
2.
2 stationary points.
And this is the one you guys will be dealing with a bit more often.
Was there a question where I had to do the second one?
Huh?
I have a question that you had to do the second one because they say they do the first one more frequently.
No, cubics just come more frequently. Cubics is what's come.
Oh, on the whole, okay.
Yeah. Now, while we on this topic, right, let's look at the nature of the turning points one time. So a cubic would have two stationary points. Cool. Nature. Right, so I'm going to use the same diagrams. Tell me, guys, tell me. The first one is a maximum or minimum turning point.
Maximum.
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 Right, there's a maximum, right? And for a maximum, you're looking to see if the second derivative is what?
Positive.
Negative.
Negative.
Oh.
Mikhail, if you're confused, right? Okay, I'm blame mine here. Enter CSEC maths, right? How do you tell if a quadratic gonna be a maximum or a minimum? Alright, let me get a refresher, right? I know CSEC maths go on the other day, forget about it all the time. Forget about it one time. Right? Okay. Mikhail, consider I had f of x is equal to minus 2x squared plus 3x plus 5. What value there would tell me it's a maximum or a minimum?
A.
E.
Well,
Over here, A is less than 0, so you'd say it's a what?
minimum.
Nah.
Maximum. So I just mix it up.
Alright, let me show you a way to never mix it up, right? Mikhail, if you're negative, which one are you? If you're negative, which one are you?
The frowning face.
Frowning face as a maximum or minimum?
Maximum.
Oh, this is odd maths, Ole. This is odd maths. This is odd maths. Odd maths paper to practice. Yeah. So, Mikhail, you ever wonder how they get that?
No, not really.
Okay. Well, let me show you something, right? Consider we find the first derivative of the function. The first derivative of the function would be minus 4x plus 3. What would the second derivative be?
It would be -4.
Oh, the minus 4. And we seen in odd maths that if the second derivative is negative, it represents a...
Oh, I know, catch.
Right. So if the second derivative is negative, it is a...
Maximum.
Right. So if it's a maximum, then the second derivative is going to be less than 0. In other words, negative. If it's a minimum, then the second derivative will be equal to what? Well, not equal to. It'd be inequality. It'd be what?
It'd be positive.
Right, so more than 0. And I've never seen this come before, but I should point out what a point of inflection is. It's a second, guys. In physics, people, and this look like a wave, like a sine wave.
Yeah.
So,
Yeah, it is. So, like, watch this, right? We're revising physics one time. Is that crest or a trough?
Crest.
Crest.
Right. What's this?
Trough.
Trough.
If I tell you that this was displacement, and this was time, this will tell you from here to here will tell you what's the wave.
Wavelength.
Wavelength.
Now, what's our trick out there?
wait,
Oh.
no, that would be
Period.
oscillation.
Period.
Would you
Period.
Time.
Yeah, that'd be
Oh.
clear because time. Yeah.
It would tell you the time it takes for one full oscillation. Trick out your bad there, boy.
Oh.
Yeah, boy. That's okay.
So you don't have proof of it.
I literally don't worry, because study physics live and I go on cook all day. Don't worry. It's fine. So here what? Over here, You have a maximum or a minimum?
Maximum.
Maximum.
You have a maximum. We know that over here, d2y dx squared will be what?
Negative.
Right?
Less than 0.
And over here, you know that d2y dx squared will be what?
Positive.
Positive.
Positive more than
0.
0.
Ah, so like watch this, eh? And it must have a point where they connected.
Yes, sir.
So you see this point over here? They call this the point of inflection. Did anybody learn that in school?
Probably did, but don't remember it at the time now.
Not yet.
Well, now you're learning it, right?
So,
So
and
the
this
point.
going under integration.
Say that again?
And this going under integration.
Nah, right now we're doing differentiation. Yeah. Integration is the reverse process of differentiation, right? So at the point of inflection, we think d2y. Wait, what we think I would say for d2y dx squared?
It's equal to 0.
Yeah, because guys, if over here it's negative, and if over here it's positive, naturally, what do you think it will be over here then, in the middle?
Oh, 0.
Yeah. If you think of it like a number line, number line, you have negative numbers here. You have 0 in the middle, and you have positive numbers here. Same way you can think about it over here. Are you understand what I mean? Like
Yes, sir.
negative, 0, positive. Cool. So let me tackle some past paper questions one time. Let me not stick. We already have the foundation we need. And well, after we do this, after we do like 4 or 5 questions, well, actually 4. You know what we could look at? Integration. Could look at integration. So Mari, I see that you say 3 stationary points. No, I wouldn't say 3 stationary points. For a cubic, you only have 2 stationary points. A stationary point is where the gradient is what? A stationary point is where the gradient is.
Zero.
Remind me, guys, a stationary point is where the what is equal to 0.
The gradient is
Oh,
equal
the
to
answer,
0.
right? The gradient is equal to 0. Do not confuse the first derivative with the second derivative. Don't do that. Question: if you find the the gradient over here, wait, that looking like a 0.
No.
Like
No,
gradient?
no, no.
Nah. Nah. So you only have 2 stationary points for a cubic. All right. Let me do some possible questions. What are you feeling like?
Very good.
25.
25. It have any? 25.
Let me see. Right. All right. Well, let me start the question from scratch now. Quickly. Let me tackle it now. So first things first. Differentiate the following expression with respect to x. Simplify your answer. No problem. So before I do anything, right? I see now they have 3 over x to the power 4. What do you think I should do with the divided by x to the power 4?
Bring the x above in the
Right.
numerator.
X minus 4.
So this would turn to sine 4x plus 3 by
X minus 4.
Nikolai, okay?
Yes, sir. What?
Now, since this is a much bigger question, are we going to do the full chain rule?
No, the shortcut.
Shortcut, right? Shortcut. Let me do the shortcut one time. So we're going to differentiate the inner function. So if I differentiate 4x, what would that be?
Cos 4x.
4. If I differentiate sine, what I would turn to?
Oh,
No, no.
Plus.
And I'll just write back 4x.
Yeah.
Badness. Nikolai, differentiate that for me.
That'd be minus 12x minus 5.
Good. I thought they would say minus 3, no. I totally was going to say minus 3. I totally was going to say that. No, no. If you have minus 4, minus 1, and minus 5, so it'll be minus 12x to the power minus 5. Badness. If you're confused, oh, where's minus 4, minus 1? Somebody tell me, where's minus 4, minus 1?
Minus
Minus
5.
5.
Right, minus 5. That's an easy 3 marks. All again on 3 marks, right?
Yes, sir.
Good.
Yes, sir.
Let me tackle B. So who wants to help me with this question? Have any volunteers?
Let's say you won't have to bring the x back down on me.
You could if you want. This is fine. I feel like that's fine, but you could always do that. Now we have a negative power. So what does that mean? Negative powers indicate what?
That fraction.
Fraction. So this would be, if you send it back to the bottom, it would be x to what power?
5.
5.
5. Right. So I see Madman say one more time, sir. No problem.
Madman.
So, yeah, somebody on TikTok. They say their name is Madman, apparently. Madman. Madman, what country representing? You don't look like I don't look like Trinidad. What country is that? Yeah, boy. Alright, so one more time. Oh, Guyana, big up Guyana. Guys, if we want to do the most basic differentiation, it needs to be in the form x to what power? X to the power n, right? And if something is in the form x to the power n and I differentiate that, what would that be?
N
The
x
to the
to n minus 1.
Good. Tell me, guys, if I have something like 1 over x to the power 4, is it in this form?
No.
Yes, sir.
No, no, it is not. So I need to put it in that form. So I'll take the x to the power 4 and bring it up to the top. So what would it become?
X to the power minus 4.
Right. Is this and this in the same form now?
Yes, sir.
So now I could apply this rule and I'll say negative 4 x to the power minus 4 minus 1, which is minus 5. So, yeah, I needed to take the x to the power 4 and bring it up to the top before I could have done anything. So I hope you understand that. And then I differentiated. Right, Madman? I hope you understand. Big up the Jamaicans and the Guyanese people that are on TikTok, on YouTube. Nikolai, you imagine like we could say this now? And Nikolai, like remember like when you joined my live for the first time and saying now I'm not addressing Trini people, you know, I'm addressing like all over people from all over the world. It's
Yes,
crazy.
sir.
Telling your math vibes to the world, boy. Hey, we're making it. We're making it out of the streets with this one.
Sir, I sure when them people finish the maths exam, the same math I say will, sir.
I hope so. Right, next year we got me big and better. Alright, determine the coordinates of all the stationary points of the curve. Quickly. Does this look like a quadratic curve or a cubic curve?
Cubic.
Cubic.
This looks like a cubic. And anytime we're talking about stationary points, remind me, what do we know about stationary points?
They equal to 0.
Equal to 0.
Gradient is 0.
Gradients is 0. So
Oh,
we'll say
yeah.
dy dx is equal to 0. So we'll have to find the first derivative and formulate an equation. So let's differentiate. So we're going to multiply a third by 3. What's a third by 3?
1. Well,
1.
it'll just be x
X
squared.
squared.
X cubed. Oh, yeah. I saying, boy. I saying, yeah. I didn't ever see that. I don't know what I'm talking about.
So we recording this in us, sir?
And then we have minus 5 over 2 by 2, which should be minus 5.
Yes, sir.
X to the power 1, which is just x. And if I differentiate 4x, what would that be?
Just
4.
before
Plus 1.
If I differentiate minus a half, what would that be?
0.
0, because these are constant.
Right. Now, we want to find the stationary points. Before we do anything, I just showed you guys for a cubic, we have how much stationary points?
3.
2.
No,
Two.
no.
2.
It's 2,
1.
2, 2, 2, 2.
2.
Or 2, yeah.
If all they don't understand, right? This is what a cubic does look like, generally speaking. Wouldn't this be a stationary point and this be a stationary point?
Yes, sir.
Yes, sir. I
Yes.
was thinking about points of intersection for some reason.
Oh no.
So
This is
when I
hard
hear
maths paper too.
cubic, so when I hear cubic, I done was looking to say 3 already.
And you had to be careful. So here what? We're gonna set this thing equal to what? Remember, this is the gradient function. And we're trying to figure
0.
out the values for x where the
Equal to
gradient
0.
is. Right.
dy dx will be 0.
So I'll say x squared minus 5x plus 4 is equal to what?
0.
Right. Now, we have to factorize this quadratic. And so here's how I do this. To get x squared, we're going to say,
X by x.
X
all
by
right, we're going to look at the last term. The last term is 4. What two numbers would multiply to give you 4, right? Multiply to give you 4, but add to give you negative 5.
So
Minus 4,
negatives.
minus 1.
Minus
-4, -1.
minus 4
minus 4 and minus 1.
All right, because where's minus 1 plus minus 4?
That could be
minus 5.
Minus 5.
All right, so minus 1 minus 4, bam. Get the answer one time, no stick. Now we could only do this for simple trinomials, eh? What I mean by that? Well, if you get like okay, I almost never use the AC method. Like for like 2 years when I started teaching, I never use the AC method. Because I just teach my students how to see it. But I realize a lot of they like to use the AC method. So I just teach that. But anytime you have a simple trinomial, this is a trinomial because there are 3 terms, right? And the coefficient for x squared is 1, you could just use this trick. Just look at the last term, ask yourself, where you had to do with 4, okay, what would multiply to give you 4, but add to give you the middle term? That's all. Minus 1 or minus 4. That's it. So then we would say x minus 1 is equal to what?
1.
0.
I did rates a change yesterday. Go on my YouTube
Oh,
video. Go on my I could do some though, don't worry. I'll show you the trick. Really cool trick. But if you want differentiation in extreme detail, go on my YouTube channel. Look at the latest video, CSEC odd maths differentiation, calculus. I did it in extreme detail there. So x minus 1 is equal to 0, so x would be equal to what?
1.
Right? Then I would say x minus 4 is equal to 0, and I'll say x is equal to.
4.
4.
And if you want to verify if your answer is correct, let me show you what you could do. If you know x is 1, right, then I would replace x with 1. Where's 1 minus 1?
0.
0,
Where's 0 by absolutely anything?
0.
0.
Alright, the same thing. X is equal to 4 would satisfy the equation as well. Because, 4 minus 4 is 0, 0 by anything is 0. Cool. No, they wanted us to determine the coordinates. Is our coordinate made up of an x value alone?
No, sir.
no.
No. So I know for a fact someone is very, very guilty. It would just stop here. No. No. Naughty, naughty. You need to look for coordinates. They want coordinates. A coordinate is made up of an x and a y value. So now that you have the x value, how are you going to find the y value?
Substitute the
Plug
x
x
into
into
the equation.
second
Right.
derivative.
No. No.
Second derivative is for the nature of the roots.
Yeah, second derivative
Yes,
is
sir,
for
my
the
bad.
nature of the
My
roots. That's okay. That's okay. We're going to use this because, Mikkel, this would tell us what y is given that you know what the x value is.
Yes,
Right?
sir.
I'm not shaming nobody. All are we learning? I just make mistakes sometimes. All right, all of we just make mistakes. It's fine. So we have y is equal to a third x cubed minus 5 over 2x squared plus 4x minus a half. So, Mikkel, what we're going to plug into this?
X equals 1 or 1.
Right? We'll say a third by 1 to the power 3 minus 5 over 2 by 1 squared plus 4 by 1 minus a half. So, what's a third by 1 cube?
That's
country.
a two.
That's it, right? 1 cube is 1 by 1 by 1, which is 1, and a third by 1 is 1. 1 third. You understand what I mean? One third by 1 is a third. What is minus 5 over 2 by 1 squared?
Minus 5 upon 2.
Minus 5.
What? And then this, that's just 4. Plug it into your calculator and let me know what you get.
4 over 3.
4 upon 3.
I'll again 4 over 3.
Yes, sir.
Yes, sir.
I trusted earlier, right? 4 over 3. Okay. So my first coordinate is going to be what?
1 and 4 over 3.
1 over 4 upon 3.
Okay. Let's find the other point.
4. So you substitute 4 into the equation.
Right. Here, we're not gonna waste no time. Just plug the whole thing into your Casio calculator. And let me know again.
6.
Minus 19 over 6. That I
I'll
get.
again minus 19 over 6.
Yes, sir.
Yeah.
Yeah.
Yes, sir.
What my other point be then?
4 and minus 19 over 6.
12.6.
Cool. Now let me show you something real cool, right? The maximum turning point, do you think it would go higher or lower than the minimum? Here what I'm saying, right? Okay, the maximum, right? Let me explain something, right? The maximum, minimum. Which one is the maximum? 1 or 2?
1.
1.
One.
1. Would that, okay, imagine it's the y-axis, right? Which one go up to a higher y value?
1.
Gonna be 1.
One.
Maximum.
This one, and this will go down to a smaller value, of course. So here what? Just by looking at this, I know that this is the what?
Minimum.
Maximum.
Minimum.
Huh.
Let me
I think
explain
I'm
something.
wrong.
Let me explain
Yes,
something
it doesn't
again,
have
right?
a
Check it out, guys. Check it out. Check it out. Logically. The maximum would go to a higher value or a lower value.
Higher.
A higher value for y. Are you seeing that on that?
Yes, sir.
Yes, sir.
yes, sir.
So like which one goes up to a higher y value? 1 or 2?
1.
1.
Gonna be 1.
So automatically I know that this is the what?
Minimum.
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 And I know that this is the what?
Maximum.
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 Right. Okay, try to think about maths differently. Maths and maths and everything makes a lot more sense when you step back and you think about it intuitively, which is why I preach. Don't just find the answer, understand what the heck you're doing. You know what I mean? Put
Yes,
some
sir.
context to it. So I feel like could I get that 4 marks?
Yeah, of course. Stationary points is a nice question.
Yeah. I'll again this 4 marks for sure, right? If it come.
Yes, sir.
I only hear Nikolai, you know. I only hear no son. I know son will get through it. What the rest of you
That's
guys?
where you get through. You get through.
Alright, Christopher, I see you laughing and saying whole class boy, you good?
Yes, sir.
Alright, Christopher, which country you from? You don't sound like Trinidadian.
No, I'm Guyanese.
Big up Guyana one time. Big up Guyana one time,
So
right?
that madman in Guyana too, right? Hey.
Hey, Matt, vibes going international, you know, Nikolai boy. Hey.
No, that
Yeah,
why
boy.
probably he was laughing because the madman also in Guyana too.
No.
Probably. So here what? And what did I say? The proof is in the proof is in the
In the graph.
I guess you could say that.
And you put in.
Right?
This is the proper thing.
Yeah, the proof is in the pudding. I think that's what it is say.
Oh, you're talking like that. I
Yeah.
thought you were talking about the what we have here right now. We're typing in right now.
That's okay. Yeah. This would be the more correct thing to say, really. So I'm going to check to see if it actually makes sense. Anthony, I see that you're confused. Here, what? Find my WhatsApp number, reach out to me, and I'll put you in the live session. I'll put you in the Zoom because it seems like you genuinely want to learn. Right? Reach out to me, and I will add you to the Zoom. Okay? Free of charge. The Zoom is free, by the way, guys. All right, so let me ask you a question, right? Predictions. When I tap here, what do you think the point should be?
On the maximum.
4/3.
143.
Are you ready? Bam. Where's 4/3? Isn't 4/3 1.333 recurrent?
Yes,
Yeah.
sir.
All right, let me check the other one. Before I do it, just tell me where's minus 19 over 6 as a decimal?
That should be like 3 point. Well, it'd be 3 and 1 upon 3.
Which
3.333
Bam.
minus 9. Yeah.
Bam.
Minus 3.33.
See, math's just bad like that, right? Yeah. Are you okay?
Yes, sir.
Sir.
Cool. Hence determine the nature of each of the stationary points found in B part 1. So remind me, if it is a maximum, what we know about the second derivative?
It is less than 0.
Right. If it's a maximum, then d2y dx squared is going to be what than 0?
Less than 0.
Less than
Less
0.
than 0.
And if it's a minimum, what we know about d2y dx squared?
It would be
0.
more
Less
than
than
0.
0.
So let's recall. So by the way, if you do understand what d2y dx squared is, it just means the second derivative. So naturally, we're just going to differentiate a what? Differentiator? A what? Differentiator. We're just going to differentiate another time. That's all. So wasn't this the first derivative?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, so we're just going to differentiate this another time. That's all. Don't want to be complicated. Just going to differentiate this another time. So if I differentiate this another time, I'll say d2y dx squared.
And dx squared.
Oh, y the squared on the... Okay. That's just how you write the second derivative. That's just the notation. That's just the notation. That's how they write it. I don't really know why, but that's just the notation. That's the notation of the second derivative. Other ways it could look like, so this would be the first derivative in this form, and this would be the second derivative. It's just different ways to represent the second derivative. If I differentiate this another time, what would that turn to?
2x minus 5.
X minus 5.
Minus 5.
2.
That would turn to 2x minus 5. Brilliant.
Yes, sir.
And now we have this function here, which would allow us to find the nature of the stationary points. So what was our values for x?
1 and 4.
Right, so we were dealing with x is equal to 1 and x is equal to 4. This is what we were dealing with. And so I'm going to plug this into the second derivative function and see what I get. Now here what, right? Here what? Just by looking at this, we were able to figure out that, this one will be what?
The minimum.
Maximum or minimum? And we figured that this one would be what?
The maximum.
Maximum.
So I feel like it might be opposite when we're doing this one here.
Should I again?
Will it be the opposite when we're doing the second derivative?
What do you mean?
Okay, so like how I say the maximum and minimum.
Yeah.
Right. When you're doing the second derivative, I have that feeling like when you put down the points and you solve it, if it could be same maximum and minimum, if it's the opposite.
Now it could be the same thing.
Oh, okay.
Watch. So we suspecting that this is the maximum, and we are suspecting that this is the minimum. Let's see. So we have d2y dx squared, and let's plug in x is equal to 1 into that. So when you're plugging in things, you could always represent it in this notation. You could draw a vertical line. You could say what you're plugging in, and then you could start. So that would be 2 by 1 minus 5. What is 2 by 1 minus 5?
Minus 3.
That is minus 3. Yeah. Guys, minus 3 is positive or negative?
Negative.
Negative.
So that would tell us that the point, that would tell us that the stationary point 1 comma 4 over 3, I think it was, yeah, 1 comma 4 over 3 is what? Is our what? Since d2y dx squared is negative,
Maximum.
Maximum.
right?
So
Since d2y dx squared is less than 0. Okay, let's do it for the other one quickly. And Nikolai, isn't that what we theorized? We said that was the maximum.
yes, sir.
Yeah. Let's quickly do it for the other one. So what we're gonna plug into the other one?
X is equal to 4.
We're gonna plug in x is equal to 4. So I'll say 2 by 4 minus 5. What is 2 by 4?
8
What is 8 minus 5, guys?
would be 3.
Are you understand now or no?
Yes,
Yes,
sir.
sir.
Okay. And so then you would say the stationary point it was 4 comma what?
Negative 19/6.
Is our what?
Minimum.
Since d2y dx squared is
More than 0.
good. Everybody getting their marks? Getting their marks for sure?
Yes, sir. I get
Yes,
4
sir.
stationary points, sir.
Excuse me,
Nice.
sir.
Yeah, talk to me.
So, like, is it true that, like, say for instance, you have -3 and you have +3 there. Is it true that you could just assume the other value to be the opposite sign? So, like, if it was 8, it could be -8.
I hear what you're saying, I hear what you're saying, but don't assume that all the time.
Okay, sir.
I mean, I understand why you're saying that, and it makes sense. It makes sense. I hear what you're saying. If this one, if that is a maximum, but obviously the other one had to be a minimum. Yes, that's true. But they still want to see it working. Still want to see it working, right? You're not wrong. You're very right, but they want to see it working regardless. Now, I am going to add in an additional question. What if I asked you to find the point of inflection? What do you think? What do you think I would do? I would do there. If I ask you to find the point of inflection, what are you going to do there?
Say we'll put the second derivative as 0 and just substitute.
Right. All you understand what I'm saying, right? If, remind me, at the point of inflection, the second derivative is equal to what?
0.
0.
Right. So here's what you could do. Here's what you could do, right? Don't we have the second derivative here? So point of inflection. At the point of inflection, the second derivative is equal to
0.
0.
correct. So we could set this equal to what?
0.
0.
And we could solve for what value?
X.
Right? How would I solve the x value?
Substitute.
Plus 5.
5/2.
Only
Like you
5.
see, like when you do not maths, right? All you're okay with this, like that's why if you do not maths, basic maths don't phase you. It's like really don't phase you. Like all of them make the subject at this, they don't phase you at all. So x is equal to 5/2. How would I find for y?
Substitute x into the y
5 times
or
2
equation.
Don't worry, we'll go back to the graph to see if we're correct. Don't worry, don't worry. We have trust in the graph. We trust in the graph. Some brave soldier plug 5/2 into this one. I trust in you. I trust in you. I am trusting you. So you're gonna plug 5/2 into this. Imagine having a sharp for this exam, boy. Damn,
So I saw people with the sharp going into the maths exams. Sir.
that's sad. They should conduct a survey examining pass rates and the correlation to calculators. Right? Plug that into the calculator and let me know what you get.
I get in -11/12.
Anybody else getting -11/12?
Yes, sir. -11/12.
Yes,
Right,
sir.
bingo. So the point of inflection would be what?
-11/12.
It would
Wait,
be
the point?
be 5/2, comma.
-11/12.
Yeah, sharp would work, but you had to put so much brackets, it's ridiculous. Right, this is the moment of truth. And by the way, 5/2 is 2.5,
Yes,
and
sir.
-11/2 is that is minus 5.5, yeah?
Yes, sir.
Moment of truth, moment of truth. So remember, this is what the point of inflection does look like, right? The point of inflection would I be like somewhere over here? And
Yes, sir.
let me see big moment of truth. Let me see. Let's see. Let us see. So I'm gonna put 2.5. Come on. That's weird. Why it's over there? I'm so confused. Why is it over there?
Sir,
That
it's 11 over 12.
Yeah.
Yeah. It's
oh,
yeah, 11 over 12, sir. Yeah, too.
Why is minus 11 over 12 as a decimal?
That could be I'm not gonna say that.
Negative
Very long.
0.916 recurring.
I just plug it in directly.
Yeah.
Right. Okay. Tango. Oh, let's see it. And then the canary point of inflection.
Yes, sir.
Yes,
Yeah.
sir.
I got scared though. I was like, best I just pack up my back one time and stop teaching maths.
No,
Hey,
no, no. Simple.
oh, hey boy.
6 can't stop you, sir.
Alright, so let's see the maths real cool. Point of inflection right there.
Yes, sir.
Yeah. So if CXC decided to throw a curveball, everybody that was here already know how to do point of inflection. Right? You know how to figure that out. It's just where the second derivative is equal to what? It's where the second derivative is equal to what?
0.
0.
Right. So here what? If you are a student that has a hard time with rates of change, listen up, because after today, if you pay attention, you'll never have problems with it again. And ask Mikkel. You can take my word for it. And Mikkel?
Yes, sir.
Yeah. Trust in the math vibes, I promise. It doesn't matter if you plug it in before or after. Okay, I had to get more context as to what you mean. Right? I see somebody say something on YouTube. Here, what? Message me on WhatsApp. I'll try to directly address your problem or address your question. All right, part C. The length of each edge of a cube is increasing at a rate of 0.25 centimeter per second. Let me underline this statement one time. So over here, they're talking about the what? The what?
The length of the edge of the cube.
The
rate of
length.
change?
Wait, they are talking about the length. And they're telling us it's increasing at a rate of. Now, anytime you see rate, you should be thinking time, yeah? You should be thinking time.
Yes, sir.
So you're seeing time here and you're seeing length. You're seeing time and you're seeing length.
Length over time, which will be
Yes. DL over.
dt.
dt.
And furthermore, guys, if you look at the rate they provided, you see in centimeters. What does centimeter mean? It looks like it's
Length.
measuring what?
Length.
And S minus 1 look like it's measuring what?
Time.
Time.
Time in seconds.
Exactly. So this over here, they're giving us what over what?
dl over dt.
Or dl over dt.
So dl over dt is 0.25. Forget what unit. So now it's writing the values. And they want us to calculate the rate. Again, on the line rate means with respect to time of change of the volume. So immediately they want us to find what?
dv over dt.
dv over dt.
Good, because the change in volume with respect to the change in time. Guys, are we going to write dt over dv?
Nah.
No, sir.
Let me ask you that question, right? Does time change because of volume?
No, sir.
No.
Think about that for a second, guys. Let us soak in for a second. Does time change because of volume?
No,
So,
sir.
like, if I drink this blue water as well, will I reverse the time?
Nah.
No,
Nah,
sir.
No. See, you cannot say dt over dv, right? Quantities change with respect to time, not the other way around. So that's dv over dt. So here's the hack, right? Here's the immediate hack. If I want to get dv over dt, let's put it on one time. I want to get dv over dt. You know you had to use chain rule here at some point. So I'm going to write, this is 2025. So if I want to get dv dt, what will I write on top here and write in the bottom here for sure?
dv and
On the
dt.
top is dv and on the bottom is dt.
So now we're looking for another variable that they could have given us in the question. Hmm. Hmm.
Yeah.
DL. DL. Let's see. You know what I see it?
Yes, sir.
Yes, sir.
Yeah. Now, students might be kind of confused here. They might be saying, sir, how are we going to find DV over DL? Well, what kind of shape are we dealing with?
Cube.
Cube.
A
Boy,
cube.
that's
A cube. Do we know the formula for volume of a cube?
Side cube, length
Length,
cube.
length cube.
Isn't
Or S cube.
volume? And we just typically say side by side by side.
Yes, sir.
yes, sir.
But like over here, since we're using length, we could just say what instead?
L cube.
Cube, L cube.
I don't understand now, no. Length cube.
Yes, sir.
For anybody that might be confused, imagine you have a cube here. I'm saying that this is L. I'm saying this is L here. Basically, you're saying all the dimensions is L, guys. That's what I'm saying. And so the volume will just be length by length by length, so length cube instead of S. And let me ask you a question, chat. Could we figure out DVDL? DVDL from this?
Yes, sir.
Sir.
Yeah, we could. So what would DVDL be?
Be 3L squared.
And let's read the question fully, right? It's saying at the instant when the length is,
8 centimeters.
8 centimeters.
so what could I sub in for length?
8.
8.
Hey, when let's see how it's actually question is a smile and just just smile, like, right? So they're telling us that the length is 8. So we're going to say 3 by
8 squared.
yeah. What is 8 squared?
64.
64.
What is 3 by 64?
192.
92.
But again, 192, right?
Yes, sir.
Yes, sir.
So watch. It's going to be 192 multiplied by
0.25.
0.25, sir.
what are we?
48.
48.
Right? And you need to put your units, right? So volume is changing with respect to time. So volume is measured in what in this question?
Centimeter cubed.
And time is measured in what in this question?
Seconds.
Per second.
So you'll say centimeter cube
Per second.
S.
Per second.
If you write cm cube slash S, that's fine, but we typically write S minus 1 because we, add maths. Now, let me show you guys something really cool. DVDL. What are the dimensions for DVDL?
Cm cubed over cm.
Right? So DVDL, what is that? That's cm cubed all over cm, which would reduce to what?
Cm squared.
Squared.
Right? Now DL over DT, what is this about? Well, length is
Length
cm.
over time.
Length over. And so if you multiply cm squared by cm over s, what would our result to be?
CM.
cube
S.
upon S.
Oh, isn't that the same thing here?
Yes,
Yes,
sir.
sir.
Maths just that cool. Maths just that cool. You know what I mean? You gotta find somebody in your life that consistent like maths. You know what I mean? So that's it. That's it. I don't think it was that hard. I feel like once you practice these questions and you see a razor change question, guaranteed marks or like guaranteed marks. The Zoom not filling or hear what? Guys, if you're interested, send my message. It's free by the way. Just send my message via my number +1 868 784 2630. Right. So let me run through the process again. Anytime you see rate is with respect to what?
Time.
Time. Time is always going to go in the numerator or the denominator.
Denominator.
Right, denominator. So when I read this first statement, I know immediately they're talking about dl over dt because the length will change with respect to the
Time.
Time.
good. So and immediately just from reading that first part, I know that dl dt is 0.25. I know that. Put that on one time, no stick. Then they want us, then we're going to look at what they want me to find for. They want us to calculate the rate of change of the volume. So again, rate has to do with time, and they're telling us volume here. So that would be what? What are we trying to find for?
dV over dt. Volume with respect to time.
Good, dV over dt. And then you look at any other miscellaneous pieces of information they're given. They're telling us the length is 8. So here what I'm going to do. Forget about everything. Just look at what they ask you for. What they ask you for?
The rate of
Rate of change of volume.
the volume.
This is what they're asking for, right? The rate of change of volume with respect to time, dV dt. So, again, what am I going to put here? What am I going to put here for sure?
dV and dt.
Right, and then we're just looking for some other random variable that would change. Oh, well, look at that. Well, look at that. dl, right?
Yes, sir.
So if I put dl here, then dl had to go over here as well. Because I had to cancel off to give you
dV over dt.
dV over dt.
right. And then you had to ask yourself, okay, how I could get dv dl? Well, I see any change in volume with respect to length. I'm dealing with a cube here. Could I find the volume of, is there a formula for volume of cube? I wonder, boy.
Sir.
Yes. The volume of a cube is just side cube, or in this case, you can say length cube. And then you can find dVdl.
Yes, sir.
They're not hard. And they told us the length is what?
8
8
centimeters.
centimeters.
So after you differentiate, you can only do it after you differentiate. After you differentiate. Not before. Not before. If you do it before, then they will be finding for volume, not dVdl. So after you differentiate, you can plug in your value for L, and you're going to get 192. Okay, understand?
Yes,
Sure,
sir.
yes, sure.
From here, just have to substitute. So dVdl and dLdt. That's it. How are you feeling about differentiation, chat? How are you feeling?
Good, sir.
Awesome,
Good.
awesome.
Master of
Nice.
doing differentiation
So
questions.
the first time I do this paper and I tried this question, I forget we was dealing with length now, and I put the volume as S. So I was doing dV over ds, and when I went
Oh, you was getting
take it,
confused.
I was like, where that coming from?
Oh, I understand. Yeah, you have to be real careful about the way you're using. Somebody said, sir, will this be posted on YouTube? Yes. My previous live is on YouTube as well, where I went over this in more detail. So where you got the tree from? Let me explain. So volume is side by side by side, but instead of using side, we're using length. So length by length by length is length cube. And if I differentiate this, I'm going to multiply by the power. So I'll say 3, and then I'll minus 1 from the power. So 3 minus 1 is 2. 3L squared. This is not paper 1, guys. This is AdMaths paper 2. Somebody asked if this is AdMaths or physics. This is AdMaths. Yeah. I hope nobody has seen my face. Because I label the video AdMaths. You know? I label on YouTube, the live says AdMaths. It says AdMaths. So, yeah. I want to do another rate change question.
Yeah, I don't mind, sir.
Yes, sir.
Yes, sir.
Okay, no problem. Let me ask ChatGPT to come up with one scene the way how CXC moving, you know?
For real, sir.
Oh, wait, actually, I have a real nice question for you. If I can figure this out, I'll be real bad. I'll be real bad. Like, real bad. Right. A tough question. It's from a paper 3. I look at it, right? I love this question. I love this question. In case I was wondering, this is what the questions in paper 3 does look like.
So when I first see this paper for paper 3, I was like, nah, I had to write that.
It's a little complicated.
So what number this question is?
In paper 3,
Yeah.
well, it's just get one question in paper 3. Sometimes you get 2, but like sometimes you just get one question.
All that working for just one question?
If you think this bad, Nikolai, if you think this bad, right? Close your eyes, Nick. Wait, actually, don't close your eyes. Advanced paper 3 is different. It's like deadly, boy. Deadly. You see, advanced paper 3, oof.
Wasn't that just now I admit?
Wait, I feel like I should have give me a second. Favorites. I'm not seeing Mrs. Mark vibes here. She should be the favorite. Unless there is, unless there is.
Yeah,
Real
yeah,
Riz,
yeah.
boy.
Yes, sir,
Riz
yes,
for
sir.
days.
And it
She's beyond impressed
recorded.
though.
So, and it recorded so she could always replay it back, sir.
And you see Nikolai encouraging my nutritionist.
So I just say it was Riz?
Yeah, but that real Riz. Yeah, so this is what the questions look like in our paper three earlier. It's real critical thinking. A lot of critical thinking. Really, really difficult. Look at this. Logs and series and sequences.
So that why I had a one shot this add maths now, or I will be doing this later and cry.
Like, look at this question. The numbers log a cube b7, log a to the power 5 b12, and log a to the power 8 b15 are the first three terms of an arithmetic series. The 12th term of the series is log b to the power n. Calculate the value of n.
So them can't just calculate n. Them had to tell me to calculate n, sir.
Yeah. If all I want, I
And
could do
so
a
what's
paper
the
three.
time frame for our paper three?
I think it's like an hour and a half or 1 hour. Brutal, you know? Real brutal.
Nah, I said I real wickedness, sir.
Watch. Oh, 1 hour and 30 minutes. This was the question for 2025. So nice question. Nice paper, actually. I wouldn't say it was that hard. Obviously, I wouldn't say it was hard because I was teach, but like genuinely, this wasn't a tough year. Look, they're asking for mean, median, standard deviation, interquartile. All the math students could answer this, low key. I sure the math students could answer this. Ed,
Simple stuff.
where's the question now I wanted to give you all, boy? Like it hiding. Like the question hiding. I need to like okay, this was a tough paper. Watch. Look at all of this. Where's the numbers? Where's the numbers, chat? This one paper, eh? And one of my students, she write AdMaths privately in 3 months and had to write a paper three, and she got two, which is a big achievement. It's a big achievement. Because I
Yeah.
sure most of you would not want to write this paper three. I sure.
Of
I
course
sure.
not.
So I
I
had a
sure.
right paper three.
Well, good luck with that. But she real smart. She real smart. So here what? Earlier, this is like a S tier level question on the higher level.
I remember this.
Alright, well, let me see if I can do it then. I'm gonna give all you 5 minutes, see if I can tackle this question. Go. I think they're gonna mark you guys like normal, to be honest.
Yes, sir. Sanya maths one time.
Okay, Nikolai. Okay, Einstein. Yeah. Something.
So I remember the procedure for this.
All right. I think I don't know. I don't think we can make it to 20. Yeah, but like if we could make it to 20, that would be insane. But like, I don't know. I don't know. Probably like 17. I don't know if we can make it to 20K on TikTok. That'll be tough. That'll be tough. But it's in the hands of you guys. You know what I mean? It's in the hands of you guys.
Yes, sir. We can share it up, sir.
Yeah, I gotta make it blow up. Yeah, that's correct, Nikolai.
I was saying, sir, like for like questions that I know might be repeated and everything, I just tell myself is that I just memorize it or understand the concept of what the question.
Understand the concept. Understand the concept. Understand the concept. Please, please. I will. I go all the place. Yeah, I rather you understand the concept than memorize anything. But you know, sometimes you genuinely have to memorize. I understand. Eh, but try to understand. You know, Nicola, you know, I still memorize the periodic table.
Well, I mean the 20 elements say periodic table, yeah.
Yeah,
What
I
do
know
you
that
know?
like I know that like my alphabet boy watch. Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, chlorine, neon, sodium, magnesium, aluminum, silicon, phosphorus, argon, neon, sodium, magnesium, aluminum, silicon, phosphorus. Like I didn't finish it, but like that's all I can remember. That's all I can remember.
Nah, but
Like
that's still very good. I think you reached 18 out of the 20.
what was the last one? What's the last one?
Argon and calcium.
Oh, okay. Not a chem teacher. Not a chem teacher. Right. Okay. Are you ready to? Okay, let's allow some time. Let's allow some time.
Yeah, lucky you got it. I'm a sim manager.
Let's allow some time. You better try. Yeah, Ash, message me. I will, I will link you up with somebody that she's doing nursing too. She's a really good nursing student. And she could help you. She could give you good advice, guide you accordingly. Right? I could probably give her advice for electrical engineering or any engineering discipline, but not for nursing. Funny enough, Mr. Sargon in nursing. Yeah. 40 seconds remaining. You guys, I hope you all getting through. Christopher, you just messaged me there. Christopher, that's you? Oh yeah, that's you. Must save your number. Nah, not Christopher. That's not correct. Like it's more like a proof question. It's more like a proof question.
Yeah, I was thinking so. Time is up.
All right, time is up. Let me run through the solution, right? And this is only harder type of question. Harder type of question. So let me run it. The ship in the game has a rectangular shaped stern shown in figure 2 that takes in water at a rate of 2500 meter cube per second. Now, here what, guys? Let's understand this logically before we do anything. Logically, you have imagine this is like a boat, right? If it's a boat, wouldn't the top be open? Wouldn't the top be open?
Yes, sir.
Yes, sir.
So, like, let me ask you all a question. What happening is, like, if you take a turn, water is going to pour in here. What is the only thing that's really changing here? Would the width and the length change?
No, sir.
Or would the only thing change here? What would be the only thing changing?
The height.
To the water.
Exactly. All you understand what I'm saying, right?
Yeah.
Here's a logical example. I have this container here, right? I have this container. If I fill water into this container, what's the only thing that's going to change?
The height of the water going up the container.
The height of the water, sir.
So all you understand that the only thing we should be looking at here, the only thing that we should be looking at here is DH what? DH what?
DHDT.
DT.
Exactly. That's very important, you know. That's very, very, very important. Does everybody in class understand that the only thing that will change here, if you pour water into this, right? If you pour water into this container, what is the only thing that's going to change? Will the width and the length of the container change?
No, sir.
No, just the height. So the only parameter we're interested in seeing changing is really the height. So we need to find dH dt. Okay? And they're telling us it takes in water at a rate of
2,500 meters cubed per second.
okay, yes. So over here you're seeing meter cube. Meter cube is suggesting what?
Volume.
Volume.
And S minus 1 suggests what?
Time.
So dV
So
over dt.
dV over dt. Stay with me, right? Stay with me. And they are saying, show that when a wrong turn is made, the stern is filled after 6 seconds. If the rate of the change of volume of water to height of the stern is given by dVdh is equal to 200 meters squared. So here was saying earlier, from the start, I recognize that I should find what? What should I find?
dH dt.
Radius.
Change in height with respect to time.
Right. Christopher, is just say radius?
No, it's a radius.
That's okay if you did, we're learning. But Christopher, do you understand the only thing that's going to change here is really height?
Yeah, sure. Because water is
And,
entering into the blood.
and as time passes, the height will what?
The height will increase.
Good. So we need to find dH/dt. Forget about everything in the whole question, right? How would you find for dH/dt? Well,
You have
what,
the at the top there, and on the right side at the bottom, you have dt.
are you with me?
Yes, sir.
Let's
Yes,
look at what was given to us. Quickly, let's look at what was given to us. We were given dV over dt. So where do you think we're going to go here?
dV.
dV, let me cook, right? And if dV is going over here, what do you think would go over there?
dV as well.
dV.
Wait. Whoa, they gave us dVdh. So would it be that hard if I wanted to figure out dH dV?
No, sir.
Yes, sir.
Sir.
No, that wouldn't be hard. All I had to do just do was R.
The reciprocal.
Exactly. So dH, if dVdh is 200, dH over dV could just be what?
1.7.
1 over 200.
Over 200.
Yes. And so dH dt is going to be 1 over 200 multiplied by dV dt, which was
2500.
and they're gonna get 2500 all over 200, which is
25 upon 2. 12.5.
25 over 2.
which is
12.5.
all again 12.5.
So when I did it by myself, I got 12.5 as well.
Okay, good. And that would be its height with respect to time. So it'd be 12.5 what? Height. What do we measure height with respect to?
Centimeter.
Right. So in other words, every time you take a wrong turn, the height is going to increase by
12.5 centimeters.
and at the point where it's filled to max capacity, wouldn't the height be at its maximum?
Yes, sir.
So what was the height?
75 meters.
Meters.
Okay, so if the height is 75 meters, could we then figure out the time it would take for it to like fill up?
Yes, sir.
Yes, sir.
Miguel, tell me how I would do that. How would I figure out the time it would take for the full height to be like fill up? If you don't understand, Miguel, tell me, according to what we just figured out over here, we know that for every 1 second that passes, the height increases by what?
12.5 centimeters.
And you fully understand that, right?
Yes, sir.
Right. So here's what so Mikel, you have any thought processes or like you don't know what to do?
Divide 12 by 75.
Right. So if you wanted to figure out the time it would take, you could just say 75 divided by 12.5. And what would that produce?
6.
Come on, Mikel, what would 75 over 12.5 produce?
6.
6. Oh, yes, good correction. Not centimeters, meters, meters. Yeah, we were dealing with meters. Good correction, right? Thanks. Yeah, look at the dimensions here. It's in meters, not centimeters. You gotta be careful. But watch 75 over 12.5. We get the 6, right? Proven. QED. Let me know if you guys understand.
Yes, sir.
Yes, sir.
Yes, sir.
And this is on the harder side for razor change questions. So, if you could get this correct, you're in a really good position. Right? People on TikTok, thank you for the correction. I changed it to meters one time. And for time, you need to put 6 what? What are the units for time?
Seconds.
Per second. Second,
Right.
yeah.
Right. Do you all understand this tricky razor change question?
Yes, sir.
All right. Cool. Okay, so I feel like we okay with differentiation. We could probably do some other stationary point like uh let's see. Do you have any specific requests, like any specific year?
2022.
1.
Wait, say before we move on, we should probably do this question, Chat, we should probably do this question. We should probably do this question. But after today, we finish with differentiation. We're good. We're 100% okay with differentiation, and differentiation is fine. All right, quickly. We have sin x over cosine x. What rule we gotta use here?
Quotient rule.
Quotient rule, right? So what would u be and what would v be?
U would be sin x and v is cos x.
Right, so u is equal to sin x, and v is equal to cosine x. Quickly, what would I write here?
That'd be du dx. Mass equal to cos x.
Right. Both of them require critical thinking, but I would say odd maths is more straightforward than maths, by the way. People on TikTok. And over here it's going to be dv dx. If I differentiate cosine x, what would I get?
Minus sin x.
Minus cos x.
Minus sin x. If you differentiate cosine x, is minus sin x. Right? Cool. So let's do the quotient rule very fast. So dy dx, it is v du dx minus u dv dx over v squared. So what is v?
Cos x.
Right? What is du dx?
Cos x.
Cos x.
Right? Minus u dv dx was u.
Sin x.
Sin x.
What is dv dx?
Minus sin
sin
x.
x.
This question real nice and all. This question real nice. SAT papers are easy. I write the SAT paper and I get full marks in the math section without revising. I didn't revise. I do kind of bad in the English section though, but I max out the math score. SAT paper is easy. I don't know why people just say SAT papers are. And the denominator would be v
Cos
squared.
squared x.
Cos x
So,
squared.
so that'll be cos squared x, right? You know what? I should just when I'm doing 24 hours, 48 hours, I'll just do a bunch of random maths. SAT, GCSE, CSEC, CAPE, SEA, just a bunch of maths. Right? Cos x by cos x is cos squared x. And then we have minus sin x by minus sin x. That would be sin squared x. So positive sin squared x. All over cos squared x.
Ah.
But you see, not to know what sine x by sine x is sine squared x, and then negative by negative is a plus.
Yes, sir.
So what is
that trigonometry thing?
yes, yes. Only remind me, what is cos squared x plus sine squared x?
1.
1.
1. So you get 1 over cos squared x.
And
And
the
that's
cos squared x is 1 minus sine squared x or something like that? Or
yeah. Cos squared
right,
x.
right.
Cos squared x is 1 minus sine squared x, and sine squared x is 1 minus cos squared x.
Yes.
But guys, remember this fundamental identity, please. Sine squared x plus cosine squared x is equal to 1, and cosine squared x plus sine squared x is equal to
1.
Wouldn't it be
1.
1?
Because addition is commutative, the order does not matter. The order doesn't matter.
Yes, sir.
Right? So I'll follow with me, and I'll follow in. And that's it. So look out for these types of questions, right? Questions where you have trig, trigs and differentiation. Right. Somebody said they wanted to do 2022. Not a problem. Let's do all the differentiation questions in 2022. And yes, if you're on the Math Vibes group chat, I will be sending all of these notes. Right, 2022. And let me speed through this now. Let me speed through this. All right. A girl who said she wanted help with this, so let me run through it together now. Let me tackle the first question. So, who was that said they wanted help with this?
So it was me.
Maya, okay, no problem. So Maya, they say given that f of x is equal to x by 5 minus x squared, determine f double prime x, which is the what?
Second derivative.
Good. So we have to differentiate how much times?
Twice.
Alright, what's the first thing I should do?
Differentiate.
But wait. Should I differentiate like, okay, as it stands right now, you might be tempted to use product rule and chain rule.
Mm-hmm.
But why are we doing that? It's to the power 2. If it's to the power 2, what you could do?
Multiply them by each other.
Yeah, and simplify. I know for a fact when the students look at this problem, I know a lot of you guys gonna waste your time and do the product rule. How much are they go do that? How much are they guilty for that? I see Michael shaking the head. I
What's
see
that?
Michael shaking the head. And anytime you see something to the power 2, don't go and do no chain rule and thing now, guys. Let me show you. So Maya, before I do anything, I want to simplify this. So here what, right, Maya? I have x by 5 minus x squared. What does 5 minus x squared mean?
5 minus x by 5 minus x.
Right? If you expand that, you're going to get 5 by 5, which is 25. Then 5 by minus x, that'll be minus 5x. And minus x by 5, which is minus 5x. And minus x by minus x is plus x squared. What would the next line look like?
X and in brackets x squared minus 10x plus 25.
Okay, for anybody that's confused as to what she did, she simplified the x terms. Minus 5x is minus 10x. Because just imagine you have a girl, and Nikolai come, and he take the first one, he take the other one, he take the other, he take 5 ax's, and then he take 5 more ax's. So Nikolai gonna take 10 ax's, right? And I hide the girl from Nikolai, you know what I'm saying? But yeah, minus 5x is minus 10x. Just imagine you're repeatedly taking x's. So altogether you take 10 x's, and well, you are allowed to take the elements here and rearrange them. Notice she said x squared here, and she said minus 10x here, and she said plus 25. That's allowed. That's fine. What would I do next, Maya?
You would multiply the terms in the bracket by the x on the outside, so it would be x cubed minus 10x squared plus 25x. And then after we will differentiate.
Isn't it real easy to differentiate this?
Yeah.
Real easy. What will the first derivative be?
3x squared minus 20x plus 25.
And the second derivative?
6x minus 20.
That's it? I just imagine for a second that you had the product rule and thing. Ooh. You know what I mean? So if you had to differentiate something and it could be simplified real easily, do that first before you differentiate, right?
How much marks is for this value?
3 marks.
Oh, that way, right.
Right, so Maya, let me tackle B part 1. Alright, so over here, 2 sine 3x plus cosine x. Am I going to do full chain rule over here?
No.
Nah, because it is within a broader question. So if I differentiate, so I'll say d dx, since it's not equal to y or anything, I'll just say d dx 2 sine 3x plus cos x, and that'll be equal to what? If I differentiate 2 sine 3x, what that'll be?
6 sine 3x.
Nah, if I differentiate sine, we'll get
6 cos 3x.
right. These people are excited for math paper 1, boy. Wow. Wow. Every minute somebody come in and they say like math paper 1. Nah, this is odd maths, CSEC odd maths. And if I differentiate cosine x, what that'll be?
Minus sine x.
Man, that's easy 3 marks there, boy.
I do the paper before.
Oh. I should change it up then.
Yeah.
I should probably change it up then. But guys, how did I do this? I differentiated the 3x, and I got 3. And I took that and I multiplied it by 2. That's how I got the 6. Then I differentiated sine. If you differentiate sine, that's going to turn to cosine. And you write back the inner function, which is 3x. If you differentiate cosine x, that's just going to be minus sine x, and that's it. Mikhail, and that is you commented on TikTok day. I know as you know, Mikhail. Hey, Mikhail playing games here. Alright. Wait. No. This is English B.
What?
If you have a strong foundation in maths, you're not gonna have much trouble in maths. Maths is generally more straightforward. Alright. Okay, so Maya, when you look at this question though, do you want to expand? Do you want to expand that?
No.
What do you feel we should do here?
Chain rule.
We should do chain rule. Well,
Quotient.
Product. Here what, right? Quotient is when you divide into functions. When you look at this, you have 1 plus 2x cubed, or operation in the middle.
Multiply.
Right, so which rule would you use?
Product.
Product, yes. So we're going to use product. So this we're calling this U. And we're going to call this what?
V.
Right, so if U is equal to 1 plus 2x cubed, then what would du dx be?
Six and then in brackets 1 plus 2x to the power of 2.
Right, let me take my time though. So I'm going to write the 3 in front. I'm going to differentiate the inside. If I differentiate the inside, it's going to turn to what?
2.
Then I'm going to write back 1 plus 2x. Take away 1 from the power, is going to turn to 2. And that's going to be 6 by 1 plus 2x to the power 2. All right, here, quickly, we have v is equal to x plus 2. If I differentiate that, what will get?
1.
Right? And so if I want to differentiate the function, I would say d dx 1 plus 2x cubed by x plus 2. And that's going to be v, come on, v by what?
V
Oh, wait,
by
I see Shivan has his hand raised. Talk to me.
So I have one question. How you get that 2 there? 3 multiplied by 2, where that 2 come from?
Okay, no problem. So first things first, right? What power is this thing being raised by?
3.
Do you want to sit down in the exam and multiply 1 plus 2x by 1 plus
That's a
2x by
shortcut
1
rule.
plus chain rule, right? So here we're going to be. We're going to take the power and pre-multiply. So I'll multiply the whole thing by 3.
Yeah.
Then we'll differentiate the inside. If I differentiate 1 plus 2x, what would I get?
Okay. I understand.
Oh, I will get 3 by 2. And then I write back the original term in the brackets and a minus 1 from the power.
Okay.
Right? So if I want to differentiate this, it's going to be v du dx. So v is x plus 2. Du dx is 6 by 1 plus 2x squared plus u dv dx. U is 1 plus 2x to the power 3 by what? Tama Maya, by what?
by 1.
Right, dv dx is 1. So when you expand that out, you can write that as 6x plus 12 by 1 plus 2x squared plus 1 plus 2x cubed. If you're confused, here what we write, you see how we have x plus 2 by 6 by 1 plus 2x squared? Here what, guys, can I distribute the 6 across the terms here? Can I do that? Can I multiply the 1 plus 2x squared by 6?
No, sir.
No, sir.
No, I can't do that because right now this is being what?
Raised to power.
Exactly. If
Yeah,
it's being raised to a power, if it's raised to a power, I can't do that. However, is this raised to a power?
No, sir.
Yes, sir.
Nah, so you could just distribute the 6 across everything. So that's why I said 6x plus 12. I just distributed the 6 across the terms. And cool. Are you seeing anything we could potentially pull out, Maya?
2x.
I was seeing 1 plus 2x to the power 2.
Okay.
See now, now.
Yeah.
If I pull out 1 plus 2x squared, what do I write inside the brackets for these?
6x plus 12
Yeah.
plus 1 plus 2x.
I could just write 1 plus 2x. Because you understand, 1 plus 2x by this, we gave back this, cool. And 1 plus 2x squared by this, we gave back this. Now, I didn't do logs yet. Could we simplify inside the brackets?
Yeah. You will get 8x plus 13.
Yep, that's correct. 8x plus 13. Guys, we feeling okay with differentiation?
Yes, sir.
Yes, sir.
Nice, nice, nice. Let me tackle this a question. That's it for differentiation. Call it a day. I think I'll have it.
Yes, sir.
Then we can move on to integration. Integration is a relatively short topic, I would say, compared to differentiation. Right, C part 1. Excuse, sir, does it matter if you pull out the 1 plus 2x before distributing the 6? No, it doesn't matter. Like you could pull out the 1 plus 2x squared if you wanted over. If you want, you could pull it out over here. It doesn't matter. It doesn't matter. In the end, you'll get the same answer. in the end, you'll get the same answer. But I recommend you do this. So I recommend. All right, so quickly, Maya, I feel like you're good since you say you do the question already. Let me ask Christopher now. Christopher, you there?
Yes, sir.
All right, Christopher, when you talk about stationary points, what we know about stationary points?
Sir, dy dx are the gradient is equal to 0.
Good. So what do you think we have to find for this?
Sir, you would have to put dy dx, well, that y equation equal to 0. So dy dx is equal to, that would be 2x squared minus 8x.
Nah,
Oh,
wouldn't be
my
2x squared. Wouldn't be 2x squared. What would that be?
Oh, 3x squared. Yeah, my bad. That'd be
3x
3x squared minus 8x plus 4.
And we're gonna set this equal to what?
0.
And now we have to do what?
First, now you have to factorize and find for values of x.
We should probably use the AC method here, seeing that, A is not equal to 1. So we'll say 3 by 4, because A is 3 and C is 4. AX squared plus BX plus C. So A is
Yes,
3,
sir.
C is 4. So 3 by 4 is 12.
Yeah.
So tell me, what two numbers would multiply to give you 12, but add to give you minus 8?
Let me see. Okay, if you do 4 and 3, that would give you 7. To give you 8. Oh, sir, no, that wouldn't work. Wait, I got it. I can't really think of it on the spot. Not even gonna lie.
All right, forget about it being negative, right? Just imagine it being positive, right? What two numbers would multiply to give you a positive 12?
4 times 3.
So that again,
4 times 3 would give you positive 12.
think of another situation.
Another situation, that would be, 3 times 4. Another one would be 12 times 1. Another one would be 6 times 2. Therefore, 6 and 2 are.
And
Yeah,
when you
6
add
and
6
2.
and when you add 6 and 2, what do you get?
You get 8.
Right, so
So it has to be like minus 6 multiplied by minus 2. So you
that's
get
correct.
positive
That's
4.
correct. So we're gonna split the middle term. So instead of writing minus 8x, what are we going to see?
You're going to say 3x squared minus 6x minus 2x plus 4 is equal to 0.
Then I'm gonna put on the Great Wall of China, right, in the middle, and I'm going to, factorize each separately.
Yeah.
So you see any common factors between 3x squared and 6x?
Minus 2.
So that again?
There'll be 3x outside.
Yeah.
And x minus 2 in bracket.
Because if you expand this, 3x by x gives you back the 3x squared. And the 3x by minus 2
minus
give you
8
back.
minus 6x.
Right. Yeah.
So
So I do have more
that's
knowledge. Yeah.
minus 2, and that'll be minus 2 outside. So that'll be x minus 2.
Correct. Here's a hack,
So
right? Here's a hack. Here's a hack. Here is a hack. So Christopher, if you do this correctly, right? Chances are wherever you get here, you will get over here. So immediately put x minus 2 here. And ask yourself, well, what would I have to multiply by x minus 2 to get back this? Minus 2. Minus 2 by x is what?
Minus 2x.
Good. Minus 2 by minus 2 is?
Positive 4.
Good. So you see that x minus 2 there, and you see that x minus 2 there. What should I do?
The x minus 2, you will just put it in one bracket.
Right, so I'll pull out the x minus 2. And if I pull that out, what would I write?
We put 3x minus 2 in this bracket.
3x minus 2 in this bracket. So if I solve for x is going to be equal to what?
Equal to 2. And x is equal to 2 upon 3.
So will it be minus? Oh, no, no, man.
Because I'll take the minus one and move it across. If I take the
Okay.
minus one and move it across, it will turn to what?
Positive, so it's 2 upon 3.
Yeah. That's it. So, but the actual stationary points is a point just an x value alone?
No, sir.
No,
So our
point.
point would be x and y value.
Correct. So we need to take these points and plug it into what?
You plug it into your y equation.
Right, what function there? So when
Yeah,
x
the
is equal to
function. Y is equal to 2 cubed minus 4 multiplied by 2 squared plus 4 times 2. Minus, that'd be 8, 4 minus 4 minus 16. 8 minus 16 plus
okay, minus
6.
16. Actually, so like that'll be 8. 8 plus 8 is 16. And then you
Yeah.
have
I feel like it's 0.
that'll be 0. That'll look like 0.
Yeah, it's 0. I feel like 0.
Right? If I'm wrong, just correct me, right? Just correct us. Alright, when x is equal to 2 over 3, you're gonna plug that in.
Yeah.
So that's going to be right, 2 over 3. 4 over 3 minus 4 over 2 over 3. Yeah.
Here you'll get 68 upon 27.
68 over 27, you see?
Yes, sir.
What about the rest of you guys? Are you all getting that?
So I think I make a mistake because I have 32 over 27.
Let me check it. Let me check it.
Oh, wait, actually, I
I
made a
got 32
mistake.
over 27.
Yeah, I accidentally topped the 6 when I plugged minus 4 into the. I got 32 upon 27 when I fixed that.
Yeah, you all got 32 over 27.
Yeah.
Yes, sir.
Yeah. So what are my points?
Sure. For the top one, it's going to be 2 comma 0. And then the bottom one is going to be 2.3 comma 32.27.
Cool.
So you gotta put like upon 27. 32.27.
Oh,
You
I
put
can put that
32
one.
upon 7.
For the other question, I do that too. I'll leave out the one. Thank you
Oh,
for the correction. Yeah, that was easy. Yeah, I feel like I'll get out 4 marks in the exam.
I have a question though.
Yeah, talk to me.
Well, it's a lazy habit of mine, and I think that's why I was doing the factorization slow. But I would normally just plug it into my calculator and do the factorization.
Oh,
So I feel that's
I understand.
yeah.
It wouldn't be. That's like beneath you. Is like, oh God, why did do factorization for me? Yeah, right, right. So that's the day. Let me tackle this question here, and then we're done with differentiation. Maybe a little break. Come back, and grind integration, and we're going till 12, so we have some time. I'll have an exam tomorrow or not?
No, not for me. I just
Right.
only
No.
have coming up.
All right. So are they ready to grind integration after this?
Yes, sir.
Yes, sir.
Right. So when you do integration, you need to know how to find the original equation of a line or equation of a graph. Basically, integration is just a reverse process of differentiation. So you would use integration to reverse differentiation. You would also use it to find the area bounded by a graph, like the x-axis and two lines, you could use it to also find the volume generated by rotating 360 degrees a revolution. I think that's essentially it, you guys. I don't know. How many questions you will see, but integration is like a real easy thing. Definite and indefinite integration, real easy. Mikhail, I see you was doing 1 over x and ln x and thing. I don't think no one syllabus, no. Is it?
Wait, is it?
I see you was doing thing like integral of 1 over x and thing, which is ln x, but I don't think no one syllabus.
No, so that was basically like the theory notes.
Oh, okay. Let me answer this question fast now. So somebody tell me if we want me to find nature of stationary points, and at the stationary points, we know that we should find the what? We should find the what?
Second derivative.
Second derivative.
So we should find the 2y dx squared. If dy dx was 3x squared minus 8x plus 4, what would the second derivative be?
6x
That'd be 6x minus 8.
Good, that'll be 6x minus 8. Six x minus 8. And so now we're going to plug in x is equal to 2. Cool. Let me figure this out fast now. So we're gonna plug in the x values. So when x is 2, we are going to sub in x's. So that'll be equal to 6 by 2 minus 8. That'll be 12 minus 8. 12 minus 8 is
4.
cool.
So how come it is right the x value as like a finite integral?
No, this is just like it's like a standard way to write it. This is a standard way to write it.
Okay, so
It's like a standard, like it's just like the formal way to write it. You know what I mean? It's like the formal way to write it. Like when you're plugging in a value into a derivative, you typically write it like that.
yes.
You don't have to do it, but it's the formal way to do it. So I will say the 2y dx squared, and I'm going to plug in x is equal to 2 over 3 into that. So I'll say equal to 6 by 2 over 3 minus 8. What would I get? Well,
Minus 4.
again,
Minus 4.
okay, you guys get minus 4?
Yes, sir.
I bet. So, the point 2 comma, it was 2 comma 0. This will be at what point? Maximum or minimum?
Minimum.
Minimum.
Because why?
The stationary
y
point
coordinate is
is more than 0.
Because d2y dx squared is more than 0. Bam. And then over here, this point here, with 2 comma 3, I think it was 27 over 12. Was it? Was it 27 over 12? Yeah, it was 32 over 27. I don't know where I get that from. Wait. That was from the last class question. I think we had to do a question and it was 27 over 12. And my brain remember that.
Yes, I need to forget to write in the one.
My brain real weird, My brain real weird. 32 over 27. 32 over 27. Right? This would be a what? Maximum or minimum?
Maximum.
Maximum.
Why? Why is that maximum?
Because point is less than 0.
That was easy, right?
Yes, sir.
All right, so or a farmer if we see differentiation. Well, differentiation is sure to come. Or a farmer if we see that. Yeah.
So imagine they bring a ratios question and you form a differentiation.
Oh, that would be hilarious, boy. That would be hilarious. That would be genuinely hilarious. But we done with differentiation. Bam. Differentiation is completed. As if a differentiation. So I give all you how long I'll break all you one boy?
I don't know anything.
So how long of a break you need?
20 minutes.
Yeah, that's
Well,
no
as much
problem.
as you
No
need, sir.
problem.
Say that again.
Much as
As
you
much as
need, as we
you need.
say.
I was also thinking that, I could probably start earlier than 6 p.m. tomorrow and just grind. We had to do integration. I'm planning to finish integration and kinematics. Get rid of that. Done that. And then all I want to do after that.
Probably
Trigonometry.
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 Trigonometry, okay.
Either
We got trigonometry.
identity. No, wait. Is it
Honestly,
identity?
the best thing to do, if we want to finish trigonometry, I want to do that in one long session. So like we could probably do like a 9 hour session and just do the whole of trigonometry. I feel.
Yeah, no problem. You see, I had to get through with trigonometry. So,
Yeah,
I wanted
how
to
to get
go
through.
that 9 hours.
How to get through trigonometry. And I see real people asking about logs and things, boy. Log and thing.
Nah,
Logs.
logs is normal.
So loves is easy thing.
Yeah, logs is easy thing. Be honest.
By chance, anybody know any chemistry teacher that doing free lives?
Nah, boy. I don't know any chem teachers. I will tell the community of chem teachers that they need to be more charitable.
So I think the rules need to come out now.
You what?
Mrs. Mad Vibes join.
Wait there. Treat me like white teas. Don't do me dirty. Yeah, type. Yeah. Mrs. Math
Yeah,
Vibes.
I'm telling you. So I'm telling you, she go edit all these videos and keep always trying to raise up, sir.
It don't work on she. Maybe it is. Mrs. Math
Is it
Vibes.
type? Is it type errors, sir?
There is no work on she.
Yeah, they try the West
Right?
Indian type errors. The
Hey,
penal errors, sir.
the only race I work on my girlfriend was the goatee. Was the beard. As the only race I work.
Was it what?
The goatee, the beard. I mean like this.
Oh, okay.
I could agree, sir. The bear does give powers.
Yeah, the beard is a powerful thing. Beard is a powerful thing. But guys, I'll see you guys back at 9:43 p.m. Trinidad time. I can't like it's so cool now that I had a specified Trinidad time because I have viewers from all over the world. About 9:43 p.m.
So I
Trinidad
wanted to
time.
make a joke here, but I feel like that people that take offense to that joke.
Guy is that guy in this joke? Is that guy in this joke?
Yeah, yes, I got it.
What you want to say 43.9?
I was going to you gotta say AM or PM for them.
Oh god. Hey Christopher, I'll come for you now. Christopher, I'll come for you.
Same thing.
Yeah. Oh yeah, I'll be back. No problem. I will do logarithms. Here what? I gonna do all the topics on the syllabus, or everything. Everything. And well the night before I gonna do a 12-hour live. Badness. Badness. Yeah. Night before the art maths exam, I gonna be here helping all you right through. If all you have any questions to ask, I'll be here.
Yes, sir.
And I'll
That live will get plenty viewers because Cohen Spring are doing his 12-hour hard maths on Saturday. So you will get
oh,
more because it's the night before now, you will get more viewers.
oh okay, okay. And I gonna do a 12-hour physics as well, like before the exam.
I will be there for sure.
What am I yawning for? It's crazy.
So
Skill
they
issue.
get you in 4K drinking energy drinks.
This is not energy drinks, bro. This is juice, no.
Ah,
Oh, and I like the diabetic friendly version, I ensure or something.
I don't know. I just buy it. I see like it have protein and thing and it. I seem okay. Yeah.
So buy a bag of whey protein. Trust.
Best I do that, yes. Best I do that. Yeah. Yeah, all right. You guys, anybody there? Are
Yeah.
you there?
Okay.
All right, so I gotta start later. I'm gonna make some food. Probably like, oh, and a special guest might be popping in when I'm a full-time admin students.
Okay,
I'm gonna
awesome.
I might do a pure maths, one question. So I'll go see how them kind of questions is going. So like I'll come back at 9:55 and we will grind then. Yeah.
Okay, sir.
Yo, you guys are live?
Yes, sir.
Yes, sir.
I gotta make some samosas. When was the last time I had a samosa, like?
What?
A samosa. You know what's a samosa?
No.
You know what's crazy? Last night.
That's crazy.
What is that anyway, sir?
It's like kind of like a wrap. How's it describe it? But it's like a thin dough, and you put something inside and you wrap it in a shape of a triangle.
Oh. Okay.
I should give this something to do all the time.
Is this sir?
Handle this question in the meantime. 2022. Do that question in the meantime. So, Michael, you just behave yourself in school or you get trouble?
You don't remember what I tell you?
You tell me
About
how like you used to like Priya, like Miss Priya and them used to blaze you. You used to get catch. When you used to like Priya,
oh
wasn't
no. So like I used to do real bad in AdMat, and like if I didn't finish copy down work or didn't finish questions and homework and thing, she would like make me like sit down, in front by where the dean offices.
Yeah.
Yeah, she would make me sit down there and finish it out and thing. Or like if I get questions wrong, because I wasn't that strong in AdMat now. But then sometime I would run away to go play football in the back now.
Oh, I see.
Yeah. And then sometime during lunchtime, you know CJ, Jim across the road. Yeah, I used to jump the back wall and go.
Michael was a bad boy, we.
It's me and a set of fellas, so we never used to get in trouble. Because Sheldon used to be cool with it now.
Oh, hey boy.
What? Wait, your parents know about this?
3/4 way, and then sometime we used to break school and go
You know
penal and
you know it's a live recording, right?
but that don't watch YouTube and thing.
Oh, okay.
Yeah, but your parents know
You know
about this?
the place in Penal where they sell jewelry?
Yeah.
Right. Yeah. Apparently they was making an upstairs with businesses and they never locked the door to that upstairs because upstairs was under construction now. And we walk upstairs and go on and we buy Subway and they sit down and you can see the whole Penal from on top of that building.
I seen you got locked up. Somebody watches recording, you got locked up, boy. Trespassing on thing, boy.
Yo, Michael, your parents ever know about this?
My uncle did see me when I did break school once, but he cool now, so he ain't say nothing.
What? Okay.
Nikolai, if you do that, your father get licks.
More than just licks. This could be memories that they would never forget or kind of thing. They will bring it back up even when I reach all I know too. You remember when you used to defense and go this and that and all kind of shit?
Yeah, they never forget that.
Them go probably still beat me up to now.
Wait, I have a special guest here. Hey, big up Amy one time. Amy, you there?
Yes, hello, good night.
Good night, good night. Oh, this is my child, big up Amy. Amy was only top hard math students I ever had in my classes before.
Good night, good night, good night.
Yeah.
You
Good
want to
night.
share some
Reggie
hard
literally did
maths?
everything. Like, yeah, and how much we did add maths in like 8 months, 8 or 9 months.
It was short, huh? But like,
It was from August the year before, right? So I think August 2024. Yeah.
I should have only hard math people actually just look like and they're like, no, 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 no. You had to do that. So like, let's see if I can explain the question, okay? I never touched a question like this in a long time, but so might be a bit rusty, but I think it's easy. But they make a typo. By the way, this is one pure maths, like, guys, not regular hard maths.
What, this?
So yeah. So get the question I read from there, Amy.
Water is flowing into an empty right circular cone at a constant rate of 8 centimeters per minute. The depth of the liquid in the cone at time t in minutes is x centimeters. The angle alpha between the perpendicular height h and the cone and the slant height is tan inverse of root 3 over 3, and the volume of the cone can be calculated as V is equal to 1/3 pi r squared h. Show that the volume V centimeters cube of the water in the cone when the depth is 8 centimeters can be expressed as V is equal to 19 pi x cube.
Right. So first of all, it shouldn't be 1 over x, eh? Well, that should be. Can't make a mistake. The volume of a cone.
Is that half?
No.
I don't know.
And volume of a cone is a 3 pi r squared h, guys.
Yes, sir.
So
Make sure I'm not tweaking. So that alone, Amy would have just throw you off bad.
Oh, I think they should have still give you the question right if they make that typo.
Yeah, it's 1 over 3 pi r squared h. That's what it's supposed to be. So they make a typo there. So they're saying that the angle theta, the angle alpha between the perpendicular height h. So perpendicular height h. So that they're talking about here. So if that's the case, then over here would be what?
H.
I'll be h as well, yeah. And the slant length. Okay, and this is the angle we're talking about, right?
Mm-hmm.
So here we're going to I see over here that the angle is being given by tan inverse root 3 over 3. And that is what alpha is equal to. They're telling you that is alpha. Because they said the angle alpha is represented by tan inverse root 3 over 3. But to drive that point home, you recall that tan theta is equal to what over what?
Opposite over adjacent.
So that root 3 is really the opposite.
Oh.
So let me explain something. If I label this, right? This is the hypotenuse. This will be the what?
The adjacent.
Mm-hmm. Now this will be the what?
Opposite.
You didn't think about that.
Mm-mm.
And so that would make the radius what?
The opposite.
Yeah, which we know to be what? Okay, you see this? If you were to rewrite that as tan alpha, then tan alpha would be equal to root 3 over 3, right? Which should be equal to O over A. So what would O be?
Root 3.
Yeah, so what was this really?
The radius. Oh.
Which is root 3.
Mm.
You understand?
Yeah. Okay,
And
that making so much sense now. And you're just fine for R.
yeah,
I just think it was the wording. I think that was the problem.
I'll continue. Okay, I didn't do questions like this in a long time, huh? But like, so I need to think. So we figure this out. We know the angle here is what? Well, what's tan inverse of root 3 over 3?
5 over 6. Right?
Well, we could say it's 60 degrees, right? I'm pretty sure that's what it is.
Yeah.
Tan inverse root 3 on 3.
But I think they
Good.
have, well, and it could be better if you do it in radians. No?
Yeah, but it's fine. It's fine. But okay, fine. We'll stick with that. Stick with radians then. Because you know, like in higher level maths, we almost exclusively use radians. So tan inverse
Again, 1/6 pi.
1/6 pi. Right. So alpha is pi/6. Yeah, you with me?
Mm-hmm.
Oh, right. And some food here. Oh, things kind of shift around. And they see in here that the depth is x. So if the depth is x, right, then what will we plug in for height? So we know that v is equal to r to the pi r squared h.
X. Right.
So you're gonna plug in x. Let me just try something. I'm just curious to see what will happen. And we said the radius was what,
√3.
right? And the height is
X.
I don't know. I'm just curious. Let's see what happen. I don't think this is the correct answer, but let me just see. And I'll multiply this by 2. Nah. That's not what I want. I thought I was on something there.
I was
Yes.
just looking to type that in my calculator to see, you know.
Nah. Let me think. Um. Hmm. So I know that. So I know that tan alpha would have to be equal to opposite over adjacent, which should be the radius all over the what?
X. No. Wait.
Remember, tan is opposite over adjacent, right? So it's the radius here. And the thinking. How do you answer this question, Mike?
They sure didn't label it wrong. The right angle triangle.
Let me see.
So you would have two unknowns on the right-hand side for tan.
So they told us that the angle alpha between the perpendicular height each of the cone, that's over here. Yeah. So that's h. And the slant length, oh god, I keep moving about. And the slant length is that, okay. And the slant length would be this. Okay. And so this would be the hypotenuse. Oh yeah, I labeled it wrong. Oh my god, that's such a noob mistake. This is the hypotenuse. Yeah, this is hypotenuse. This is the adjacent. And this is the what? Did I label it wrong? I don't think I labeled it wrong.
Yeah.
Nah, not correct, sir, because the angle, the opposite, go had it be opposite it.
That's radius over there. And well, it's similar triangles. If it's similar triangles, then
They had the same 90 degrees.
yeah, this would be x, and this would be some unknown, but the angle must be the same. I think I onto something. So the angle will be the same, right, Amy? Same angle, same angle. So the angle will still be pi/6. You agree? And it's pi/3. No, it's pi/6, right?
Yeah.
Yeah,
That's
5/6, sir.
So that's pi/6. So the angle. Okay, so this is x. This is an unknown, and this will be some ratio of the radius. Will be the full radius.
So he wasn't given any information on the sides?
Nah. However, I'm seeing here. So the original, so that'll be x over h, and x over h should be equal to the ratio of the new radius to r. They didn't give a specific length. Tan inverse. Alpha is equal to wait, I thinking. I feel like I gotta do this question off screen. But I think I can figure it out. I don't think the question that hard. I don't think the question that hard.
So
Don't
what
know why
about that? Put it in a chat GPT.
nah, like I want to figure it out myself. That's like the honor, you know what I mean? It's like the honor. Let me run through the facts again. Let me run through the facts again, right? So we know that this is the h, that would be h, right? We know that this would be the hypotenuse, and this would technically be considered the adjacent. And well, this is the opposite. We know that. Cool. And we know that tan alpha would give us root 3 on 3. That makes sense. You following now so far, right?
Yes, sir.
Right. So Amy, and we know that tan alpha is equal to O over E. So then O, the original radius would have to be what? The original radius would have had to be what?
Root 3.
Had to be root 3. Right, stay with me. And E, which is the adjacent, which is the full height, would have had to be what?
H.
Okay.
What?
Now I have a feeling that instead of writing, now that wouldn't really affect anything. If I write 1 over root 3, it shouldn't really affect much. And E is 3. Okay, and the angle here, we know for a fact it is pi on 6. So what I'm saying is, and you understand that this would be a similar triangle?
Yeah.
And if it's a similar triangle, wouldn't the ratio between the sides be equal? Meaning that, like, okay, for a similar triangle, let me show you what I mean, right? So, like, check this out. If I tell you that this is 7, I said this is 14, and I tell you that this is 8 until this is 16, then the ratio between consecutive sides would have to be the same. So, like, 14 over 7 is
2.
2, and 16 over 8 is
2.
cool. So that's the logic I'm thinking. That's what I'm thinking about. And so let's apply that to this question. Do we know what this is? Nah, we don't really know what that is, right? You understand? We don't really know what that is.
Mm-hmm.
Don't really know what that is. We could, however, we could call this what? We could call that
We could just call it 3.
x. Watch. If you're looking at this specific triangle,
Oh.
then
Mhm.
that would be x, right?
Yeah.
But that tree, what does the tree represent? The tree actually represents this full thing over here.
Oh.
You understand?
Yeah.
So here what I'm thinking. It's a similar triangle. And so it's going to be image over object. the image is going to be X. That's the new triangle. And the original thing was what? What was the original length each?
3.
3. And that must be equal to some other ratio. Which would be this unknown all over root 3. Okay. So we need to represent this in terms of something. So let me cook. I'm gonna cook. So Amy, this would be, again, this would be the hypotenuse. Yeah, what would this be?
The opposite.
Yeah, this would be the opposite. And well, this would be the adjacent.
Mm-hmm.
So I want to represent the opposite in terms of some other thing, because right now I don't know what that is at all. So I could say, I'm gonna try something. So tan alpha would be equal. I don't know what the opposite is, so I'm gonna involve that. And I know my adjacent. I know that my adjacent is x. And I know that my angle is pi over 6. And that would be equal to the opposite all over x. What is tan pi over 6? Remind me. What is tan pi over 6? Should be root 3. It should be root 3 over 3.
Yeah.
And so if we wanted to represent O in terms of x, then O would really be root 3 over 3x. That's what O is. Remember, O is what we didn't know. We didn't know what this was. And so what I'm thinking is maybe we could plug that in over here. I'm going somewhere with this. Like I had to be going somewhere with this. That's what O is. So I could say root 3 over 3x all over 3. That had to be equal. So x over 3. And that'll be root 3 over 3x multiplied by 1 over root 3. Yeah, well, it's definitely correct because again, x over 3 is equal to x over 3. But I don't see how that's going to help me much. Yeah, I don't see how that's going to help me much. Oh, actually, wait. So V is equal to a third pi r squared h. Okay, I think I'm cooking. So, Amy, when you fill up the cone to this level, right?
Yeah.
What is the quote unquote perpendicular height?
X.
X. And what's the radius? Didn't we find for the radius?
Mm-hmm.
Yeah, we found that to be what?
Root 3 over 3x.
Yeah, I think I figured it out. So 1 over 3 pi, that will be root 3 over 3x squared, and the height is x. Yeah, I figured it out. Or else stupid boy. Hey boy. Yeah, watch it. 1 over 3 pi, that gonna be square root of 3 squared is just 3. And then 3 squared is 9. And that'll be x squared by x. That's gonna be a third pi. 3 over 9 is just what?
1/3
Right. And where's x squared by x?
x cubed.
And Amy, where's that third by a third?
1/9.
Yeah, but we figure it out.
This for 5 marks is crazy.
Nah, it wasn't that hard. I just kind of, I didn't do these kind of questions in a long time, kind of thing. Yeah. Yeah, boy. Let me run back again since I understand what happened. So, Mikkel, the answer is almost never ChatGPT. It's in your brain. You just had to reach for it. You know what I mean? No ChatGPT, just pure logic. So let's just see me struggle with that question, but you see, I did get the answer. And so I feel like that's all it is being the exam. But you just give up before you reach anywhere. Nah, you can't give up. You just have to keep going. You know, if it makes sense, you have to keep going. So Amy, I'm going to run it back again, right? Let's run it back from scratch. Ooh, cut it. My iPad freeze.
So those amount of messages you receiving, yeah, your tablet go freeze. Yeah, iPad, my bad.
Yeah, everything freezing, boy. All right. Yeah, so Amy, let me tackle this question, right? Properly this time. Yeah, so Amy, we're dealing with a similar triangle problem. And remind me, if we're dealing with a similar triangle problem, then the ratios between the image and the object would be the. I think you confused us to one me marathon.
Yeah.
Okay, no problem. Imagine I had this shape here, right? Imagine you had this shape here. And, I blow it up. Let's just say I blow it up like so and make it bigger. 1, 2, 3, 4. All right, so let me just say that I'll like a benefit from this, like hard maths people, the critical thinking.
Could you repeat what subject is this again?
This is, one pure maths. So if you're going to stuff like further your studies in maths, you have to do some keep. Yeah, so Amy, you see this is 2, right? That's 2.
Mm-hmm.
What's the bottom length there? What's the bottom length there?
5.
5. I cannot cheat in here just to prove a point. But what's this dimension here?
2.
And what's this dimension here?
5.
I see now this is 2 diagonals here. 2 diagonals is not equal to 2. 2 diagonals. And we have how much diagonals here? 1, 2, 3, 4, 5. 5 diagonals. What I'm trying to prove here, Amy, is that the ratio between consecutive sides are going to be equivalent. So you see how we have 5 here, we have 2 here.
Mm-hmm.
Then the ratio is going to be 5/2. What about the ratio over here? What's it going to be?
5/2.
Ratio over here, what's it going to be?
5/2.
See, I had to remember that for similar triangles, right? Maybe you might have to do some algebraic manipulation. You had to remember that. And in the question, they are telling us directly that the angle alpha between the perpendicular height h of the cone and the slant height is that. But Amy, wouldn't that be for when if the cone is fully filled to the max?
Yeah.
But is it filled to the max there?
No.
No, it's not. And so here we're saying, from this, we could actually figure out quite a lot of information. So tan inverse root 3/3. So they're telling us that tan inverse, they're telling us is tan inverse root 3/3. Now let's try to recall what tan is. What does tan say? What exactly does tan theta say? Tan theta is what over what?
Opposite over adjacent.
Tan theta is opposite over adjacent. Good. And so if I have something like tan inverse root 3/3, and they are literally telling me that it represents the angle alpha. So you see, they are telling us it represents the angle alpha. That's what it's saying, right? That's what it's saying. Yeah.
Mm-hmm.
So if tan inverse root 3/3 is equal to alpha, then how do you suppose I would write it in this form? So like, let me get a hint, right? So like I could say tan. So in other words, tan alpha would be equal to what? I'll help you out. So tan alpha will be equal to root 3/3. And let me explain something. Check how this makes sense. If you wanted to find for alpha, what would I do?
You know, inverse.
You'd have find tan inverse of what?
Retrieve over 3.
Which is this, right?
Mm-hmm.
Making sense?
Yeah.
So I'll run it back one more time. So they gave us tan inverse root 3 over 3, and they told us that that was equal to alpha. You need to be able to make the connection that that is equivalent to tan alpha. And again, this makes sense because forget about everything, right, Amy? If you had to find for alpha here, how would I do that?
Well, tan inverse or root 3 over 3.
Which is what was provided to us in the question, right? Isn't that what it told us?
Yeah.
Okay, good. And we know that tan is equal to opposite over adjacent. So in other words, root 3 would have represented the
Opposite.
and 3 would have represented the
Adjacent.
good. Let's try to link that to the question. So they're talking about the perpendicular height h. This is the perpendicular height h they're talking about. This is h. And they're talking about the perpendicular height h. And what else are they talking about?
The slant height.
The slant height. By the way, guys, the Unit 1 Pure Maths exam is tomorrow. So that's why helping out Amy. Amy need the help.
Yes, sir. That's no problem, sir. We learning new things as well, sir. Although looking real confusing, still.
Now I'll explain it back to you. Like, it really easy. I just kind of didn't do any questions. I just in a long time. But I proud of myself. I figure it out on the spot. That's good. That's good. Yeah. And if I could figure it out on the spot, all I could do it too. So Amy, you can see that right angle triangle. We can see that this is the slant length. So is what would we call this? If I label any right angle, what would I call that?
The hypotenuse.
I'd call this the hypotenuse. And what would I call this?
Adjacent.
And coincidentally, it also refers to h, does it not?
Mm-hmm.
And this over here would be a what?
Opposite.
And that also corresponds to what? The what of the cone?
Or the radius.
The radius of the cone, yes. The radius of the cone. So here's what I'm telling you. We know that O is root 3. So therefore, therefore that would have made the full radius what?
Wait,
That would have made somewhere in the back again. So this is what they gave us in the question. They told us that tan inverse root 3 over 3 was equal to
alpha.
And from that, we could have figured out that tan alpha is equal to root 3 on 3. And we said that, root 3 represented the
Opposite.
and 3 represented the
Adjacent.
good. On the diagram now, we can see that we have the opposite, adjacent, and the hypotenuse. So what did we say the opposite corresponded to?
The radius.
Which is?
Root 3.
Yeah, which is root 3. So this is root 3. And the hypotenuse, well, the adjacent will correspond to what?
3.
Right. Say with up to this part?
Yeah.
Right, people in the AdMaths class, if you're actually following along, let me know if you guys understand, like, okay, the first part of the question, they were talking about the angle alpha, and they said between the perpendicular height h and the slant height. And so they're telling us that, tan inverse root 3 on 3 is literally equal to alpha. So I know it's a bit, I'll ask for help in tricks, right? I know it's a bit hard, but this, guys, that is the same thing as tan alpha, which is equal to what?
Opposite over adjacent.
Opposite over adjacent.
Opposite of adjacent.
Yes, that's correct, but we know that, right? But it's equal to what?
Root 3 upon 3.
Or root 3 over 3.
Which we know to be equal to
Alpha.
Nah, that's not equal to alpha. This is equal to alpha.
Pi upon 6 or pi upon 3.
Opposite over the
Oh, yeah, opposite of adjacent.
I know it's a bit weird, right? But Nikolai, I encourage you to think about this, right? If you have tan alpha is equal to root 3 on 3, how would you find for alpha?
Yeah, tan inverse of root 3 over 3.
Right, so tan inverse root 3 over 3 is equal to alpha. So think reverse now. Wouldn't that just be tan theta is equal to root 3 on 3?
Yes, sir.
Or wouldn't that be equal to O over A?
Yes, sir.
As if that's the case, then O would be equal to what?
Root 3.
O will be equal to root 3. And A would have to be equal to what?
3. Wait, so they give you the information, but in a way that you have to think about it.
Correct. And so now you need to look at the diagram. They're talking about the perpendicular height h, that this is the perpendicular height h, and this is the slant height they're talking about. Okay,
Yes,
so
sir.
now you're gonna label this accordingly. If this is the angle in question, right, Amy? If that's the angle in question, Amy, that's the angle in question, then this would be the adjacent. You with me? That's the adjacent.
Yeah.
This is the hypotenuse, and this is the opposite.
Mm-hmm.
Now you're seeing here that root 3 represents the
opposite.
right, and A represents the,
Adjacent.
and we know the adjacent is
3.
good. So O is root 3 and A is
3.
good. And so you understand that the full height really is
3.
good, and the full radius is
The full radius.
yeah, like imagine the thing
root
fully
3.
filled up. Exactly, good. Say with me so far, right?
Mm-hmm.
Good. Now here what? Is our cone fully like filled up to the max?
No.
No, it's not filled up to the max. So is the radius going to be more than root 3, equal to root 3, or less than root 3?
Less than root 3.
It's going to be less than root 3. So here's what I'm going to input that into my diagram one time. So I know I need to figure this out. I know I need to figure this out. That's the problem there. That is the problem there. Because do you understand that if I want to find the volume of a cone is a third pi r squared h.
Mm-hmm.
Yes, sir.
But Amy, do we have the new radius?
No.
You say now unsure, but are you seeing it anywhere?
No.
No. So we need to find for that somehow. We need to find for that somehow. Yeah, you understand what I'm saying?
Mm-hmm.
You sure?
Yeah.
Okay, so how are we gonna find for that? That's the question. So I employ you to think about the smaller triangle. So we know that the angle is what? Well, if you find tan inverse or root 3 on 3, you know the angle is gonna be what?
Pi over 6.
So you know the angle is pi over 6, correct?
Mm-hmm.
You know that we calling this what? What are we calling this?
The adjacent.
What are we calling that? Calling that x. Which is the adjacent? Yeah, you're right. Do we have any idea what this is?
No.
No. Do we have any idea what this is?
No.
No, we don't. So we need to figure out something. So remember I told you about similar triangles, right? And how like, the ratios would be equivalent.
Mm-hmm.
Okay, good. And so if I tell you about that, right? If I told you about that, then wouldn't the ratio between here and here be the same ratio between here and here?
Yeah.
Yeah. Understand what I'm saying? So like this is like a little bit. This is the full thing.
Mm-hmm.
This is a little bit, but this is the full thing. And so like if I'm coming up with a ratio, it's always the image over the object. So what was the original height?
3.
3. And where's the new height? What's the quote unquote new height?
X.
X. So I could potentially write that as
3 over X.
you
Right.
typically put the image first. So like if say X over 3,
Mm-hmm.
and now that have to be equal to this new thing over here, You understand? So this new thing over here,
Mm-hmm.
I don't know where it's a question mark. Over what?
Root 3. Yeah.
Now you can use this to check if your answer is correct, right? But I don't think we had to do this. But you could use that to check if your answer is correct. If it's correct, you'll get that. Yeah. But anyways, Amy, we don't have to do all this. I don't remember. We don't have to do all this. Amy, you see how you tell me that this is the adjacent?
Mm-hmm.
What would I make this side?
The opposite.
This is the opposite. Fellas, what would that make this side? This side is the what?
Hypotenuse.
All right. So Amy, clearly the problem is we don't know what the opposite is, right? We have no idea what that is. Yeah, no idea, none.
Mm-hmm.
And this is important because to find the volume of our cone, we must have the what?
The radius.
Exactly. You must have the radius. Do we know what this is?
No.
No. Would it help if we knew what it was in terms of x?
Yeah.
It would. So here's what I'm thinking. How could I represent this in terms of x? Well, I don't know what it is. So I'll just tell you this, fellas. I'll tell you this in maths as well. If you don't know something, underline it. And whatever you have, underline it. Until you know, I'll just tell you that.
Yes, sir.
I just always tell you that. And so, Amy, we're using opposite and adjacent, right? So which trig ratio I going to use?
Tan.
Right? So I'll say tan pi on 6 is equal to,
The opposite.
which we know is we know this is the, related back to the diagram. This is what we're trying to, this radius. Yes, yes. So if you wanted instead of writing, oh, you could write what?
R over X.
Good. And what is tan pi on 6?
Root 3 over 3.
And could you represent the radius in terms of x?
Yeah.
What would I have to do if I want to do that?
We could cross multiply. So
I could cross multiply, or I could just do what's on both sides since I want to make r the subject. I want to make r the subject of the formula.
Send the x over to multiply over 2 and 2 times x.
Yeah. So Amy, if I want to make r the, remember, I don't know what Amy, I remember I don't know what r is, I don't know what r is. I have no idea what r is. None. So I need to make r the subject of the formula. So Amy, right now we have r divided by x. So what would I do if I wanted to find for r? Amy?
yeah, wait, and let's say cross multiply. So it would be like 3 r is equal to root 3 over x, and then you just divide both sides by 3.
That's fine. Yeah, you can do that. But what I was saying now is like you could also just multiply both sides by x.
Well,
Yeah, but you could cross multiply is fine. You're comfortable with cross multiplication.
yeah,
So if you cross multiply, will you?
3r is equal to root 3 over x.
Root 3 over x. Nah.
Sorry, root 3 by
multiply by
x. Sorry. And r
Also-
will be equal to root 3x over 3.
Aha. Aha. So do we know what the radius is in terms of x now?
Yeah.
So forget about
So-
this. This is just something you can do to check if your answer is correct, right? If your answer is correct, then the ratio must be maintained. And if you don't understand what I mean, Amy, watch. You understand that the ratios must be maintained, right? For like a similar triangle.
Mm-hmm.
And so watch. If I wanted to verify, watch. We'll check it, right? We know that the radius is root 3 over 3x. Right? The root 3 and the root 3 would cancel off to leave you with what over? Like what? What over what?
Oh, x over 3.
Right. Thus proving that you're correct. But you don't have to do this. This is just to see if you're correct. So here what Amy. Do we now know what the new radius is in terms of x?
Mm-hmm.
And so if this is the case, we can go ahead and find the volume now. So the volume, remind me, for the new, okay, for like where it's filled up to, right? What is the height considered to be?
X.
Height is considered to be x. What is the radius we found in terms of x?
3x over 3.
So now we can just work it out. So v is equal to a third pi r squared h. And so what is r?
Root 3 x over 3. I forget the x.
Oh yeah. Nikolai, take it from her. That's Amy. I have a running gag going on at Amy. I'm not that Nikolai taking everybody X.
Oh no.
Yeah. And what's H?
X.
Right. Let's work this out fast now.
Wait,
So
so I get back your X.
you get mine back. Thank you. Thank you. Why would I want it back though after? Anyways. Stick to maths. Stick to maths. Yeah, so Amy, what is root 3 squared?
3 x
What is
squared over 9.
always 3 squared?
9 and then
Always
x.
x. I'll just be x squared.
Mm-hmm.
You see any light at the end of the tunnel?
Yes.
Yeah.
I will see the light after 11:30 tomorrow.
For sure. And 3 over 9 is what?
Oh, 1/3 x squared.
And well, x squared by x is a third by a third is what?
1/9
And well, x squared by x is
x cubed.
yeah. QED.
I still find this for 5 marks is crazy though. So much thinking. And just 2 hours and a half, like, come on.
I don't think it's that bad. I just feel like it's a lot of critical thinking
Yeah, that's the only thing that would take up the time. So
because the similar triangles might throw you off. Like it cannot throw me off. You don't need that. That is there to check if your answer is correct, but you don't need to do that really. The main thing here is I need to know the angle. This angle over here will remain the same no matter what the height is. You understand? Fellas in class, all you understand that no matter how high I fill this thing up, right? This angle gonna remain the same.
Yes, sir. Cross-section.
Yes,
Well,
sir.
yeah.
And that's like one of the key things in this problem that I need to realize. And another thing, Amy, again, you don't know what the radius is. For you to find the volume of a shape, I mean, for you to find the volume, you need to know what the radius is, right? But you don't know where it is. So when you had to think, right, how would you find that? Well, you have the angle here, you have the angle there, and you know that this is what?
oh, x.
Right. You could find this in terms of
X.
good. I think you're okay. You okay?
Yeah.
Right. So let this be a lesson to everybody. ChatGPT is not the answer. All the answers in your brain, fellas and ladies.
ChatGPT
All
does do things wrong.
yeah. And when you figure it out, it'll stay with you. You know what I mean?
Yes, sir.
Right. So Amy, you could take your little screenshot.
Yes, hold on. Okay, thank you so much. I want to leave now.
All right, no problem. Best of luck in the exam. You have it.
Thank you. Good luck with all your and admats. I will do great.
Yeah, that was smart.
Same goes to you with your pyramids.
Thank you. Bye.
I mean, sir, if you did explain to me this, right, I can work out some questions like these, but then again, I do hard maths.
So,
But it's looking fun though.
yeah.
Yeah, it wasn't that bad because, like, I feel like you had to read that more than once to actually figure it out.
Yeah. Imagine I could do a question like this, Nikolai, in one go, but that ratios question with the cake and thing though. with the butter and thing boy. I hear that question. Right, let me I'll get you the integration question and give you a
It's an integration question.
I'll give you all an integration question.
So that was the 2022 question.
Mm-hmm.
Oh, yeah.
It was easy or hard?
Simple.
I wouldn't say it was hard, but I wouldn't say it was easy neither.
Okay.
I agree with that.
Let me see what the question is.
It was the 2022 number 5.
Let me tackle this. Integration at this level, real easy. We only had to use substitution, and integration by parts, and recurrence relations, and reduction formula. You're not gonna like that. So, Mikkel. Right? If I integrate sine x with respect to x, what would that give me?
Cos x.
You sure?
Say that, sir?
You sure?
If you integrate sine x.
Let me show you something, right? I'm about to tell you. Integration is a reverse process of
Differentiation.
right. If you differentiate sine x, there you go.
Cos x.
So if I integrate cos x, what would I get?
Sine x.
Okay. If I differentiate cosine x, what would I get?
Minus sine x.
So I have a question, right? Stay with me. If I differentiate minus cosine x, what would I get?
Minus sine x.
Nah. So okay,
Oh, sine.
Mikhail, differentiate cosine x for me. If you differentiate cosine x by itself, what would you get?
Sine x.
Well, cos x by itself is minus sine x. We have the minus sign here as well. So it's minus sine x.
Minus sine x.
But Mikhail, Mikhail, it's not complicated. You don't have to be complicated, you know. All
I
right,
feel
Mikhail,
like I have a brain fart right now.
that's okay. That's okay. So Mikhail, if I differentiate cosine x, what would that be?
Minus sine x.
Good, you're with me, right?
Yeah.
What would happen if I multiplied both sides by -1?
Yeah. Well, you get positive sine x and you'll get negative negative cos x.
Good. So tell me, Mikhail, if I integrate sine x, what will I get? Again, integration is just the reverse process of differentiation. So if I differentiated minus cosine x and I got sine x, then what would happen if I integrate sine x?
You get minus cos x.
Yes. Yes. So tell me, Mikhail, if I integrate sine x, what would that be?
Minus cos x.
Yep. Plus c, because I don't have any upper and lower limits.
Yeah.
This is indefinite integration. If I integrate cosine x dx, what would that be equal to?
It'll be sine x.
And if you're confused, Mikhail, remind me, if I were to differentiate sine x, what would I get?
Minus cos x.
Nah.
If you differentiate, say the cos x.
Good. And say if I integrate cosine x, what am I supposed to get?
Sin X.
Yeah.
So you catch me while I was doing a vectors question, you know, so my bad.
That's okay. So watch, Michael, you see it. When I integrate cosine X, what am I getting?
When you integrate it, it'll be sin X.
Right? Look at that there. And look at it here. If you integrate cosine X, what again?
Sin X.
Yeah. So remember this, guys. If you integrate sine X, it is minus cosine X. If you integrate cos X, is equal to sine X. So let's answer this question then quickly. So if I integrate 4 cosine theta minus 6 sine theta, tell me, Michael, what would happen?
You'll get 4 sin theta minus 6 cos.
If you integrate sine theta, what's happen? Remind me.
Get
If I integrate sine, what does get?
minus cos theta.
Right.
Will be 4 minus cos.
And so what would the answer be?
It'll be 4 sin theta plus 6 cos plus c.
Yep. So Michael, tell me, if I integrate sine X, what I'll get?
Cos X.
Nah.
It'll be minus cos, my bad.
I'll drill this in your head, you know. If I integrate cosine X to dx, what that'll be?
Sin X.
Good. Nikolai, if I integrate sine X, what that'll be?
Cos X. Which is minus cos X.
Yeah, fellas. Yeah. Nikolai, let me show you something, right, Nikolai? Integration is a reverse process of what?
Differentiation.
Right. If I differentiate sine X, what do I get?
Minus cos X.
Nah.
Okay. It just be cos X then?
Yeah. And so therefore, Nikolai, if I integrate cosine X, what do I get?
Minus sin X?
No.
Listen, nothing to do with sin. Minus sin X then. It's just sin X or cos X.
Look at it, Nikolai. Look at it. When I differentiate sine X, what I get it?
Cos X, yeah.
So to reverse the process, I would integrate cosine X to get back what?
Sin X.
Good. If I differentiate cosine X, what do I get?
Sin X.
Nah.
Well, minus sin X, my bad.
And so if I multiply both sides by -1, what happen?
Well, the sin X will be positive and the cosine X will be, the cos X will be negative.
So therefore, Nikolai, if I integrate sine X, what would I carry my back to?
Minus cos X.
Good. You understand?
Yes, sir. I think, yeah. Yeah, I probably have done the same thing, yeah.
You just have to remember one, you know. I just go back. So I'll say that again. If I integrate sine X, what I'll get?
Cos X. Or is it? Is it minus cos X?
Yeah.
Yeah, minus cos
What?
X.
I'll make a table for you to take a screenshot of, right? Mikhail, if I integrate sine X, what I'll get?
Minus cos X.
Good. If I integrate cosine X, what would I get? Nikolai?
Sin X.
Mm-hmm. Take a screenshot of this, please, guys. Don't forget it. Christopher, I want to test you next.
I get through.
All right. Christopher, what would the integral of minus sin x be?
Integral of minus sin x would be positive cos x.
He bad. He bad. Because Nikolai, watch this, right? If I'm telling you minus sin x, figure out what the minus sign for now, right? Just put the minus aside. If you integrate sin x, Nikolai, what would that be?
It would be cos x.
Check the table, check the screenshots or the notes you take down.
Yeah. Well, oh, it'd be minus.
So minus one minus is that?
Positive.
It's giving you all real trouble, but
Wait, let me go to it again. Let me see if I can do it.
no problem.
Kaha is giving me trouble, sir.
So let's run through the thing in extreme detail. So integration. Integration is just the reverse of what, fellas?
Differentiation.
Differentiation.
Good. So here what, let me go all the rules in reverse, right? If I were to differentiate x to the power n, what would that be?
NX.
NX. No. Yeah.
Instead of n minus 1.
Right, nx to the power n minus 1. So fellas, tell me, how would I go from here to here?
The reverse. The differentiation. The
I would
integration.
have to,
Instead of multiplying, you would divide, which is the opposite to multiplication.
good. So all you understand, if I am integrating something, you know what this do, Shivan? What would I have to do if I want to get back to this? Well,
So they got to differentiate it.
no, where's the opposite of?
If you're going from the right to the left, they got to integrate.
So to integrate this, I would divide by n, and then I would do what to the power?
Add.
Add 1. So the n and the n would cancel off. And what is n minus 1 plus 1?
N.
N, and I would take me back to this.
Yeah.
So you can see, integration is just a reverse process of differentiation. Hopefully you understand that. So when you're integrating, you divide by the power. And what else do you do?
1.
Add 1 to the power.
Right, and add 1 to the power. Okay, so let's do a couple examples. Say we wanted to find the integral of 5x to the power 3 dx. How would I work that out?
Divide
4
plus
divided by 4.
plus the power undivided.
Nah.
Add 1 to the 3, which would make it a 4, and then you take that 4 to the denominator. So it comes.
Yeah. And
Are you
you
sure
add
about
1 to the power undivided.
wait, Nikolai, look at this process, right? Look at this process.
Yeah.
How would I go from here to here?
Well, yeah, add the powers.
Yeah, we'd have to add 1 to the power.
Yeah.
And then
divide.
Right. So when I add 1 to the power, what will it turn to?
The original value of n.
Right, and then I would divide by
N.
Good.
By the right, that's what we just said.
Oh, that's all it was, Solomon.
Yeah, add 1 to the power undivided.
For some reason, I wasn't hearing that. Yeah, so 5x to the power of 4 divided by
4.
good plus c. Right. Let's do a more complicated one. What if I had to integrate 1 over, and don't forget the plus c, Don't forget the plus c. Don't forget the plus c. The plus c is there because you don't have any bounds. You're finding a general solution. What about a third x to the power 9 dx? What would
It'll
that be?
be 1 to the x to the power 10 over 10. So I was doing integration earlier, and I feel like everything I was doing, like it just go poof.
Oh gosh. Now here what? Dividing by 10 is the same thing as multiplying by 1 over what?
1 over 10.
Yeah.
All over that.
Yeah.
So that would just be 1 over what?
1 upon 30.
1
X
over
to the
30.
plus c.
Oh, plus C. Yeah.
Right.
Are you doing the sine and cosine thing now, sir?
No problem. So Nikolai, remind me, right, Nikolai, if I were to differentiate sine x, what would I get? Remind me.
It'd be minus cos.
Nah.
Oh, wait. Cos. I thought I was done thinking about the integration already.
Nah. So Nikolai, if I differentiate sine x, I'll get cosine x.
Yeah.
So think about it. If I integrate cosine x, what do you think I'll get?
Sine x.
Right, because I will go from here to here.
Right, yeah.
Remember, integration is the opposite of what?
Differentiation.
So we reverse it. Okay, good. So let's drill that again. So Nikolai, the integral of cosine x is?
Sine x.
Right, positive sine x.
Right.
Integral of sine x is?
Minus cos.
Hey, lucky, I get tired, boy. W in the chat for Nikolai, boy. W in the chat.
Right.
Oh, wait. Yeah, good. Right, so Nikolai. Let me show you why. So Nikolai, if I differentiate cosine x, what would I get?
Sine x?
You sure about that?
Or is it minus sine x? It's minus. I'll go with the minus.
Right. So Nikolai, imagine you multiply by -1 on both sides. Imagine you do that. What would it turn to?
It will be d over dx, which is minus cos x equals to sine x.
Right, so Nikolai, hear the logic, Hear the logic. If I'm going back from here to here, I gotta do what?
Integrate.
Right, so if I integrate sine x dx, what would I get?
Minus cos x.
Good.
Plus c.
So truth be told, you really just had to know one, and you could figure out the rest from there. So this is the intuitive way to remember it. So like if the derivative of sine x is cos x, and if you integrate, you go back to sine x. If you differentiate cosine x though, you get minus sine x. If you multiply both sides by -1 though, that'll be minus cosine x. If you want to go from sine x, if you integrate sine x, you'll get minus cosine x. So let me drill the thing now. Let me drill the thing quickly. Shifen, the integral of sine x is?
Negative cos x.
Right, Virginia, I'm not sure if you're still here, but the integral of 5 sine x dx is?
Sorry, I didn't hear you say.
Integral of 5 sine x dx is?
5 minus cos x dx.
Right, so minus 5 cos x dx.
Oh.
Essentially what you say. Any of the other ladies here? Or they're gone? I feel like all the other ladies gone on.
Yeah, my friend Megan went to bed.
Okay.
Sam here.
Okay, nice. So our question for you, right? What's the integral of minus 5 cosine x?
Me?
Yeah. Oh, it's some other student had
5
said it was
sine 5 sin x.
Right. Because if you figure out about the -5, figure out about the -5 for now. Well, I think where's the integral of cos x?
Negative sin x.
Alish, do you think that's correct?
Nah.
Nah, watch. Remember this? If you integrate cosine x, you get sin x. And so, put only -5, and if you integrate cosine x, what do you get?
Sin x.
Good. So -5 sin x dx. So again, let me just give you all something to take a screenshot of. So, Kylie, if I integrate cosine x dx, what was that going to be?
Sin x.
Right? Sin x plus c. If I integrate sin x to, what will I get?
Minus cos x.
Good. Take a screenshot of this guy. Don't forget this. Do not forget this. Do not forget this.
Sure. What about the instance if you have something like cos 4x, like, or sin 4x would get the negative reciprocal of the value?
I was now going to get there, you know. Chris, boy, I read my mind, boy. I read my mind. Right. So let me tackle that. So say you had something like cosine ax dx. Right. So Nikolai, look at this problem, right? If you're doing the shorthand version of the chain rule, you typically differentiate and you what?
Yeah, man. What?
Okay, when you're doing the shorthand version of the chain rule for this, right? You typically differentiate the inside and you where do you put that?
On the outside?
Right, so you multiply.
Yes, sir.
If it's integration, do you think we're going to multiply or divide?
Divide.
Good. So all you had to do instead, so Nikolai, if I integrate cos, what I get?
Sin x.
I will get sine, and so that'll be sine ax all over.
A.
Yep, that's all. Right. So Nikolai, if I had the integral of sine ax dx, what would that be equal to?
It will be minus cos ax over a plus
Good.
a.
That's all. Integration is light work, fellas. Integration is light work.
Light work. Just need a little refresher, sir.
Yep. If I start the session early tomorrow, you go join?
Of course.
What time
Yes,
is it
sir.
tomorrow,
Sure.
sir?
Like
How
3
early, sir? At the question, how early?
like 3 o'clock or something, guys.
Yeah.
Yeah.
Yeah, no problem.
Yeah.
Okay, because I'm okay feeling tired. You know what? I can't see all they want to do in the 48-hour live. I want to pop in every like here and
Yes,
there.
sir. Yes, sir.
Shivan, you look like a man that's like maths. You like maths?
Yes, sir. Yeah.
That's good. That's good. All right. So let me do a little recap, right? On integration. So again, integration is the reverse process of what?
Differentiation.
Differentiation.
Good. Let me integrate a couple of things before we head out. If I had the integral of a third x to the power 7, how are you doing now?
Add 1 to the power and divide it.
Right? So I'll add 1 to
Yeah,
the power.
third x
So the power is going to turn to what?
8.
1, well, 8. Divide by 8.
Multiply by
1 over 8.
I can multiply by 1 over 8.
1 and 4. 1 and 20. 38.
Yeah? Are you understand or not?
Yes,
Nah.
sir.
Good.
Virginia, you see now?
Yeah, I said nah. I got lost there.
No problem. See what you was going to tell me divide, right?
Yeah.
That's correct. That's correct. Well, let me ask that question. Dividing by 8 happens to be the same thing as multiplying by?
Oh, 1/8. Yeah.
Right. You understand now?
Yes, sir. Thank
I
you.
just say that because like which looking easier to work, right? 1/3/8 or 1/3 by 1/8.
Definitely multiplying.
Definitely. What is the
But
integral?
one more question.
Yeah, talk to me.
Do you always need to just add C? What does that represent?
Okay. It's a good thing you mentioned that. It's a good thing you mentioned that, right? Check this out. Stay with me, right? Check this out. Consider we had a function, our original function, and the original function was 7x squared plus 3x plus 9. You remember I told you guys that, integration would undo differentiation?
Yes, sir.
Yeah.
Yes, sir.
Yes, sir.
So here, let me differentiate the function. Let me differentiate it.
Yeah.
Now, if I differentiate this, what will we get?
14x
plus 3.
3.
Plus 3.
Okay, so Virginia, stay with me, right? So Virginia, according to this logic, if I integrate dy dx with respect to x, I'm supposed to get back what?
Is
What's supposed to get back, Virginia?
Y?
I'm supposed to get back y because integration does what to differentiation?
The opposite?
Exactly.
Undo
It undoes it, right? Good. So stay with me. So we're gonna integrate 14x plus 3 with respect to x. Now on the left-hand side, this is gonna turn to y. Because if you integrate dy dx with respect to x, you can think of it like the dx cancels off, and dy is the difference in y, and integral just means an infinite number of small sums, and so that would give you y.
Oh, okay.
In the class tomorrow, I'll go explain in more detail, but how much of you guys here didn't know that integration is just like an infinitely small amount of sums between two bounds?
Well, I didn't know. I didn't do
Like, did you realize it's like an infinite sum of small rectangles on the curve or something?
Yeah, that is Simpson's rule or trapezium rule. Back in the day, what they used to do, they used to like put a bunch of trapeziums to approximate the area on that curve. Then Isaac Newton come along and invent calculus. Right, but anyways, Virginia, look what's gonna happen, right? So on the left hand side is gonna turn to y. Let's see what's gonna happen on the right hand side. So Virginia, integrate that from us. So again, we're gonna add 1 to the power and then divide by the new power. So this is understood to be 14x to the power 1. So cook.
So 14x squared divided by 2.
Good. And then
3 squared divided by 2.
now. So here what, guys? This is understood to be 3x to the power 0. X to the power anything to the power 0 is what?
1.
1.
Oh.
And say it add 1 to the power and then divide by 1, which will essentially just give you what?
Give me back 3.
You're giving it 3x.
3x? Oh.
Yeah, because what's 0 plus 1?
1.
Right, so x to the power 1 all over 1. What is x to the power 1?
Oh, that would just be x. So 3x.
Exactly. Run it back one more time for you. So all constants could be represented as the constant by x to the power 0. So 3 could be represented as 3 by x to the power 0. And if you integrate that, we're going to do the power.
Add 1 and divide by that power.
So that would just turn to what?
3x.
Good. So when I integrate 3, that's going to turn to?
3x.
Now I'm going to leave all the plus c, right? I'll go see where I'm going with this. They'll be like, oh, it's 14 over 2.
7.
No, guys, nth integration is supposed to undo differentiation.
Yes, sir.
Yes, sir.
Let me compare. Let me compare. This is what we start off with, and after undoing the differentiation, this is what I end up with. Something missing.
The 9.
The 9 function.
Is that why
Virginia, something missing. You see in that?
Yeah, 9 is missing.
So that's why we say plus c to cater for any constants that would have been lost in translation. And
Oh,
Virginia, if I give you a point on this graph, do you remember that if you have a point on the graph, it will satisfy the equation of the graph?
yes, sir.
So if I were to give you a point on this graph, and you could have plugged it into this y and the x value, and we could have find for.
C?
Excellent. And yet I guess C is 9.
Oh, all right.
Yeah, so that, my friends, is why you put plus C. Because sometimes when you're differentiating and then you integrate back, you lost some constants you get lost in the source, you know what I mean? So
Oh,
like
So if
you're
you give
like
us a point on that graph, we could find what C is. We plug in
exactly.
Y, we plug in the X value.
And let me give a little example that I know now. Why not? What we essentially doing here is a question that could come in the exam. They could tell you, given dy dx is equal to 14x plus 3, find the original equation of the graph, given that this is a point on the graph. That's what CXE could ask you. So like, let me just graph this function here. Y is equal to... So Virginia, you understand why plus C is important, right?
yes, yeah, I understand. Thank you.
When you integrate, you're actually finding a general solution. And when you have a specific point, you find the specific solution.
Oh, okay.
Because you understand, and technically, if you don't know what the constant is, and it could be like an infinite number of constants, like you don't know where it is. You don't
Yeah.
know where it is. So again, that's why we call it indefinite. Because like C is it could be an infinite amount of C's, right? But if I give you a point on the specific line or the equation on the graph, wouldn't that give you like a specific solution?
Yes, sir.
But if you don't know what C is, and that would just be a general solution, and you could say C is anything.
Oh, yes, sir.
Yeah, so C could be 1, 2, 3, 4, 5, 6. C could be anything. But until I give you a point on the line, you can't tell me anything specific.
Okay, that's fair enough.
Right, so right, let me just say we have a point 0, 9. Now that's too easy. Are we too? No.
Definitely not that.
Let me just plug a value for x into this and cook. Give me a value for x.
3.
3, okay. Fellas, and if you have a point on our graph, what will it do to the equation on the graph?
Satisfy.
Yeah. So let me just say I give you a point, right? And I tell you the point was 3, 81. Hence, find for C and state the equation of the graph. So go, Ollie, handle that. So I'm telling you that the point on the graph is 3, 81. Hence, find for C and state the equation of the graph. That's all I want you guys to try.
Let's think about that.
So I got 9. Let's see.
Yeah, I got 9 as well.
Okay. Watch.
Oh.
Watch.
Yeah.
Oh,
Yeah.
yeah.
I see any badness, right?
Yes,
Yeah.
sir.
Yes, sir. Yes, sir.
But if you don't know what C is, then your solution is indefinite, meaning that like it represents a general solution. It's only gonna give you a point, you'll find the specific C value. You know what I mean?
Yes, sir. I understand. Thank you.
If I don't tell you the C value, then your solution is indefinite. That's why I put the plus C.
Oh, okay.
And
Mikhail?
is the y-intercept?
Yeah, that's correct. Mikhail, a way to find for C. Make sure you get 9. So Mikhail, make sure you get 9. Plug that in and make sure you get 9. Hey Nikolai, we hit 16K on TikTok. Check.
What?
Yeah, boy.
You
Badness.
close to 20 already, sir?
Yes,
Yes, sir.
boy.
Okay.
Good. So
The
here what?
81 minus 72.
Right. So here what? And Mikhail, I'm not sure if you realize, but isn't that the original value for C?
Yes, sir.
Yeah. So when you're integrating, you generally put plus C because when you integrate, you're finding like a general solution. That's what you're doing. And on the understand, if you differentiate and you had a constant, what happens to the constant? Shivan, if you differentiate a constant, what happens to it?
So the constant just can't go vanish, go poof.
Yeah, it's gonna vanish. So anytime you integrate, you need to cater for that by adding what? Thomas?
So my constant working just now, a plus C.
Good. Nice. Add matters vibe. So I'll see you later tomorrow. Tomorrow we go tackle we go finish up integration. That shouldn't take long. And we go finish the whole kinematics and real work tomorrow. Real work tomorrow, guys. Real work tomorrow.
I have one request.
What's that?
Complete this square.
Complete any square? Well, that
For
easy.
tomorrow.
That easy.
Sir, I don't know why. It just don't stick in my head, sir. I don't know.
You could use the formula, but you could use the formula, or you don't like the formulas.
Sir, I'll make my own formula. And it's still not sticking in my head.
Way boy. Well, I will see how I could fix you up, right? But yeah, guys. Peace and love. I had an all day. Later, guys. Have a blessed night.
So you didn't
too.
see how much percent your
Bye-bye.
pencil was on?
Oh, it was on 6-7. That's crazy, blood. That's